It is time. All right. I think, oh yeah, I didn't see this one yet. Test, hello. It sounds different. I don't know. It's like louder. I'm louder. Everything's louder. Whatever. Okay, so I've got this. Okay, I've got two things. I need this top one. It was, I'm trying to remember what it was for. It's part of making it so, yeah, I think, no. Okay. I've already made a commit, so I can't overwrite that one. So, this is gonna be... I'm just gonna say, like... Apply rest correction always. Make rest corrections apply even in deterministic. Still reads in the current pose. So enabling rest correction is needed for a custom iterative skeleton use cases. Fine. I don't know. Basically, I needed that because even though deterministic is documented and everything around skeleton and iterate reads as turn on mutable bone poses, so we include the current pose. If you don't turn it on, we ignore the current pose and we default to the rest pose. And deterministic, it will always reset the pose. It doesn't reset the pose, it actually just loads in the pose. In fact, let me verify that. Doesn't, I'm pretty sure deterministic literally says it resets the pose. I think it uses those exact words. Resets. If false, the result is calculated from the previous frame's result. The previous frame's result is discarded. The new result is calculated from the bone pose, excluding... Okay, so it doesn't say reset the pose. That's fine. But deterministic is definitely not a good name for it. It should be like... That checkbox should say... copy pose or something. Okay, so this is Make it so I can pass immediate. Okay. I should really use the ticks. It's pretty lame, and your voice is reverberating? Is it? Is it just loud? I'll go listen. Hello. Test sentences. It sounds fine to me. Nothing's wrong there. It's pretty lame it doesn't actually advance skeleton. Hold. So I added a parameter to immediately process the skeleton at the call site. I think it's too loud. Maybe. Maybe. It is turned up, though I think I turned that up a while ago. I would not have just turned that up. I don't know, I think it's the right volume. This mic is weird. It's actually really quiet if I don't have it slightly turned up. I'll do this. It's really fighting me there. I turned down a little bit. Very slightly. I do have like limiters and filters on it. And I did see that when I was talking right onto it, it was just constantly peaked. So that's not good. Why do I have a 5 millisecond sync offset? I don't know. It shouldn't really even change anything. I think I was probably just doing that just to mess with it, and now it's just stayed like that, so. Get status. Nothing there, it's all pushed. Okay. Oh yeah, I need to send that as a different one. Change. Change physics tick pause to physics frame. Use scene tree signal physics frame. Oh wait, doesn't, hang on. Doesn't this actually fix, does this fix signals? Or what am I trying to say? Does this fix flush queries? It does not. It still happens down here inside of physics process. So it still always runs one more than I want to. Okay. Change the leg step behavior to be mostly an internal state. Act when unexpectedly removed from the ground. I need to set up a test for that. Legs should not pay attention to any step parameters of other legs. Only the ground and comfort states. Perhaps think of steps is roughly asking its neighbors, hey, are you okay if I were to intentionally come off the ground? Neighbors should say yes or no about itself and its neighbors. Okay, I need to set up a test. I don't have a test for this. Also, okay, I actually might not be able to do that right now because I actually have some other issues where the crawler doesn't have friction right now. I need to like reorganize this area. Maybe I'll just do this. Yeah, I'm gonna rotate this stuff around. Oh wait, that actually worked? Wow. Usually when I do it, they all sit in like the same spot and then they all rotate individually. Those are actually some good values. Though it should probably be that these bridges are sitting at 0. Is that right? Yeah. Wrong thing. Too wide, then just need 1 and -1. Or this one will actually be -1. And then Z should probably be 0. I kind of did this the silly way. I should have just like taken them all out of the parent node and then moved the parent node to where I want it and then retry. Like, yeah. Oh well, I'm basically already done. Yeah. I'm trying to remember what I wanted. Right, I wanted to have just a raised platform with one of these elevators going up to it. A large one. So... where's the big ramp? I'll do this one. The height of this one is 5. And then I guess that thing is broken because it's not updating. It's fine. And this is like the width. Do 10. My scripts just suck. Yeah. Oh, well, of course I actually wouldn't see it because it's inside of the thing. Some 5 meters up, so it should be 2.5. Okay. I'll do this a little bit differently. I'll do... No, I think I want the... Okay, no, different idea. This is gonna be a cylinder. Yeah, I need to delete that. I'm gonna have a giant cylinder. That, radius. How much is 10? Yeah, okay. And then height, 10. Why does it place them like that? It's kind of annoying. What's the interior angle of an octagon? I'm just gonna guess 20. That was very close. 24. I actually don't know how I would even calculate that. $135. Am I thinking about this right? 135 degrees? So if I were to rotate it 135 degrees, it'll be a full turn. So if I did that divided by 2. Okay. And then could I do that divided by 4? Divided by 2 again? No. I could do 90 minus this quantity. Okay. 22 and a half. It was that. All right. Yeah, and then this is just going to be somewhere. I don't exactly know where to put this. Over there. Okay. So the idea is this, one of these faces will just have an elevator. This one's an elevator. Side length of an octagon. I don't even know. I'm just going to guess it. I don't think there's a way really to calculate that because this is actually a circle. I can also just look at it. It is a little bit less than... It's a little bit less than 8. Is that just 7.5 meters? It could be. What's the size of the crawler? I don't know. Yeah. I've got a weird layout for this. It's almost exactly 7.5. I think it's less than that. It's definitely not big enough for it. So here's a good question. How can I make a smooth... I guess I would actually just make it so it doesn't collide with this shape, right? I don't know. I'm saying I don't know a lot. Why? Stop it. Alright, let's go in the elevator. I think the idea was I would be testing one of these legs being detached after a moment and seeing what happens there. That was the test. This will be going up. Uh, 9.9 meters. And then I still need to have a better way to set this stuff up. It should have an acceleration force and then... Okay, so it actually... It does not do well at all with this. Oh. I put that in the way. Let's fix that. Let's do negative 85. And then 175. Let's do 170. There's like a lot of lag when that hit. That was really strange. Okay, so it looks, I mean, okay, well this would be fixed because I'm going to actually do something where its legs can't do that, where they're going inside of the ground. But it is, wow, I made it. That's cool. I didn't think it would do that. Interesting. I still have a lot of printing. Which means I've committed a bunch of printing. That's just dumb. Okay. I'm trying to think of like what I could do about that, because what probably should have happened. The wiggle is so weird. I don't understand why it does this. It's definitely the friction. The friction has like some crazy values going on here. It's just shooting off. Whoops. Right now, it decides its offset by its legs. I think it's possible I should have sort of like a third offset, where if there is ground very close to the bottom of it, that becomes like another, or maybe even like a very high impact, like a very, let me think of this, let me think about that. So if I had another raycast at the center of the body, or even just taking the main body shape and doing a cast down, if it, wherever it collides with something, that becomes its target offset, or that becomes like a lower bound. So whenever it's being lifted up by like the back four legs and the front legs are falling down, I think what should happen there is it should really try to favor keeping its body off the ground. Because I think, yeah, it kind of immediately spins forward and falls down. Though now I might be getting too far into something there. Because then it's the case that if that's happening, it should probably back up, right? How does it know to back up? It doesn't know that. I have to tell it that. I don't think I want to do that. Though it would be cool. I feel like even just seeing that happen, there's like a level of, if this were to lift up and it would try to keep its body the same distance off the ground, start rotating, and then from that information realize it could back up, that'd be something crazy. But I don't think so. I don't think I can do that. I can do that. I don't think I should do that. I don't think committing to that is a good idea. So what was I trying to look for? Right, I think I have it the wrong way around. I think I'm supposed to, yeah, I mean to put him up here on this and have the platform descend. Which I don't even think I can do that. I can plug in a negative value. So I guess I'll see what happens with that negative value. Oh, wow. All right. Huh. I mean, maybe it fits, maybe it actually kind of fits what I'm going for here, to see how it handles ground disappearing from underneath it at this. This is crazy. It seems like it has no idea this is happening. Though it is falling. I believe it still thinks it's grounded, even though it's not. Put a leg here. I think it's just teleporting. Yeah, I think it's just teleporting. So it's a really useless elevator. It's not actually moving. Though it does appear like it's moving because there's like frame interpolation happening. So it like renders it in at the in-between positions, but it's not actually moving, it's just teleporting. Okay. I'm gonna turn on all the debug on the legs, because I think it doesn't realize that it no longer has ground. I guess I can render these. I don't need ground normal. Okay, so it is processing that it doesn't have ground there. But that also doesn't make sense because it can't support itself like this. That's not a supportable configuration. I think I know what's happening. It's I've set it up so that anti-gravity is kind of overpowered. Percentage of legs necessary to lift the body. Okay, so it's actually supposed to be falling here. What if I made it half? I guess this is half of its legs needed to lift the body. But making it half should make it far more unstable, yeah. Yeah, okay. Okay, so that seems reasonable, even though it's definitely not realistic at the moment. Let me see. I can see exactly. Oh, yeah. What this means is that those middle legs are actually getting almost all of the power, right? That's how this would have to work. I want to see this. Let's print this. Yeah, the two middle legs are basically just taking on all of the lifting force. So it actually is possible if only the two middle legs were doing anything, which is exactly what's happening. The two back legs are taking on a very small amount, which I'm not really sure how they're able to take on any. But yeah, it's that makes sense. Okay. I mean, it also just kind of makes sense in a general way that the body center of mass is obviously on top of the flat part, so it shouldn't be able to fall off anyway. Invalid assignment of property key RID. Invalid assignment body RID with a value of RID on a base object. That's not a real error, that's just nonsense. Body RID exists. It is an RID. Get RID has returned an RID because it says that it's an RID. And then the base object is this is a real object. So I don't know what that is. Also, why would setup even be running right now? Or why would it? I don't know. That's dumb. Hi, Dylan. Palm Beach Pete is running for mayor. Where? Where is he running? All right, I mean, I don't know. This is just a demonstration that I've obviously made a very good... I'll stop right there. Well, if he wants to be mayor, maybe he should stop running and get in the office. Did you think of that? Okay, so they definitely handle being suddenly detached from the ground. They did handle other things. I need to fix this elevator. This elevator is just crazy. I, of course, cannot handle negatives because this code is actually really, really terrible. Okay. I was seeing that this one has a strange rotation, and I do need to fix that. This one's not really acceptable. Yeah, so legs go the right way, the whole body rotates the wrong way. And it's super odd. I take that to mean I might just have the wrong calculation here. So I'll just print out angular acceleration. I guess I could also think about what this means, because no, because even when a leg drags, this is going the wrong way. Because the reason it rotates this way is because, okay, I don't need to look at it from this angle. I just want the camera, this camera. Right, so it takes a step. It's actually already, it had a, okay, let me just run it and see. Yes, the negative values is making it rotate the wrong way, generally. But I do see some positive values. I'm trying to wait till I see... I mean, really, if I think about it, this shouldn't be a negative rotation here. Okay, so I just got 2 frames of really high rotation. And then it goes negative. One sec. Maybe I need to see each individual leg. Turn my heater off and it's still going. So I'll put this for every leg. Percent. Okay. So every leg right now is applying positive angular acceleration. There's... Okay, so half are... Okay, so there's the Z is controlled, the X is controlled, the y is overwhelmingly already a positive rotation. Which in this case actually becomes a negative rotation, which is not the way that I want to go. I want these values to read negatives. In fact, I would prefer them to read either equal or all negative. They're all positive. The wrong way. So I'll just step up here and look at one of these. Any of them. The first one's good. Okay, so I've got a leg ground velocity of... I don't really want to look at that one. I want to look at... leg ground relative contact velocity. What would drive... this leg, it would be... This is the velocity of this leg on the ground, and we're facing this way. So this leg is basically going this way, so it would have a positive z and a negative x. Is what I expect to see. It has a negative z and a negative x. So it thinks it's going this way. Or actually, it thinks it's going this way. Ground velocity is 0 right now. No. Leg. Ground relative contact velocity. So large negative x, small negative z. So it thinks the leg is being dragged this way along the ground. The relative contact velocity. So this leg is moving this way along the ground. I think that doesn't really make sense. Yeah, given its location... Okay, let me skip to a leg that I know should be really obvious. Leg 2 or leg 3. 0, 1, 2, 3, yep. Leg 2 or 3. So continue, continue. This should be leg 2. Leg 2. So I expect this one to have pretty much no change on the x and a very positive z. Or rather, it should actually just be 0. It should be stuck to the ground pretty well and not really have any change. Gosh, that's so annoying. Okay, leg, ground, relative contact velocity. It has the largest negative, it has a large negative x and a positive z. So this leg thinks it has traveled this direction. It has traveled basically like here and here is what it thinks this leg is doing. This is the direction of this leg. Which is definitely not correct. Coca-Cola will kill you if you melt and drink the bottle. Do we know that for sure? Have we demonstrated someone doing that and dying? You can try. I could try. There may even be a feedback, because if the body is rotating this way, then that means the leg is moved this way and then traveled back. But no, okay, so here's the thing. The ground relative contact velocity is definitely wrong on all of this. It should be registering a no... It should basically not be registering any velocity at all. Okay, so let me find where I calculate this. Here. Alright, so next tick. I did this wrong. Okay, maybe this is what's happening. Maybe it's the fact that it has moved slightly, which means target last global position is actually not entirely correct. Because what happens is we're here, we move with the ground down, and then it thinks that we've moved that way. But then I guess ground velocity... let me skip ahead until I get to index 2. So that's going to be this leg right here. So it should just be basically moving down, maybe a little bit on the positive X, I think. Yeah, maybe mostly positive Z, a little bit on the positive X. Okay, so the ground velocity looks correct there. Now, my leg velocity should pretty much be the same thing. It should be very close. It's very, very close. Okay. It looks like I've actually moved a little bit further than that. Which means... in this case, the velocity makes it look like the leg is... That is the way it's moving along the ground, right? That makes sense. So, this leg seems fine. It believes that this leg is generally pulling... this way, but that's fine, right? So if I were to apply friction in that case, that'd be good. Okay, so I think that ground relative contact velocity of this leg is correct at this point. So then, here's the question. What happens when we get to here? And I will skip it to the next leg and see this one. So this one I expect to see basically the same number, but the signs are different. Yeah, same number, different signs. All right, so I'm happy with that. This leg here, oops, on the right, is going up and a little that way, which is fine for it to be a little off, but it does have some effect. It's not ideal. positive x, negative z. Positive x, negative z. Basically like this. Like 9 units up and 1 unit across. So it's very, very accurate, I think. So this is the way the leg is moving on the ground. Yes, all that's right. Hey, continue. I'm going to check these legs. So 2, I should still have the same values. The relative contact velocity. Wherever it is. Like 2, negative on the x, positive on the z. Negative x, positive z. Like 3, negative z, positive x, right? So this one's pointing this way, this one's pointing that way, right? So that's very... Or wait, was it? No. This leg is pointing that way, this leg is pointing that way. So it's definitely... This rotation should apply to the body. Just from these two legs. So then what I'm going to see is that it's calculating it the wrong way. I don't care about those lines. Didn't apply that. Leg force. Yulia. Okay, so we took... Yeah, we take off any slide from that one, so this is not a friction force. Now the friction is leg ground velocity. Which leg ground velocity? Am I looking at the right one? I'm looking at the wrong one. I need to skip ahead to 2. Yeah. Ground relative contact velocity is this. This one is just not that value. Okay, so let me check this. The ground relative contact velocity should go down very slightly in the x and go up to 5. So I should see 0, 0, 5 and 0, 4, 3 roughly when this runs. Okay, that's alright, that's right. This tooltip is definitely wrong. This tooltip is so incorrect. That's insane how incorrect that tooltip is. Alright. Yeah, that value looks about right. We just take the y coordinate out. Okay. So now we're taking the ground relative contact velocity dot with the normal. So this is just impact, right? So basically just extracting that y value. Yep, basically just extracting the y value. So that's fine. Now friction. Friction, what do I expect to see here? I mean, it's just taking the leg ground velocity times the mass, right? So it should just be the same value but larger. Yeah, okay. Same value but larger. This is leg 2. I'm going to keep verifying it. So this is a slightly negative x and a very positive z. So this leg is pointing this way. This is an impulse in this direction on this part of the body, which by all intents should definitely be that way, right? Or I mean, the camera's reversed, so this way, 100%. There's no doubt about that. So I've summed it all up. That still looks good. Now the angular, what's the angular result then? Okay, so the angular is very high on the z, surprisingly. And then a positive y. I don't really care about the x. So a positive y value is what I've gotten. I'm just looking at this to see what this one says, because I think they describe it. Rotational velocity. Let me... someone describes exactly what a positive y is, because you have to look at it from a certain way, and then it's counterclockwise, right? I think if it's a positive value, looking at it from the y-axis, a positive value means counterclockwise from this direction. A negative value would mean clockwise. So I know that this thing is rotating that way. Oh, I can actually see. I know which way this rotates. A positive y. The body is oriented normally. Okay, so positive y means counterclockwise looking from the y-axis. All right. So then the angular is wrong, because I'm subtracting it when I probably should be adding it. Let me check the leg ground point. Also, state is definitely the main body, right? Yeah. And I'm about to print it as well. What was I going to look at? I was looking at the leg ground point. Okay, so leg ground point. Just going to copy that value. And I'm going to put lackey. What? Sure, whatever, right? That's fine. I think, actually, you know what? Yeah, technically, I think it's correct to apply it not from the ground point, but from the IK target. That's probably whatever. All right, but that's correct. I'm taking that position, and I'm making it relative to the main body, and then I make that position relative to the center of mass of the body. This might be why it's unstable, because this actually should be a positive. Okay, well, if I know if it's counterclockwise, this leg could only be applying a clockwise torque, which means, well, I mean, I say it can only apply, it could technically apply the other way around, but debug there, jeez, that was really hard for me to find that. Okay. That was the hardest print it's ever done. Hardest print that's ever done. Okay. So the Y is definitely correct. The y is definitely correct. The leg forces in the right direction. So I think what this just means is that I should be adding it instead. Or I could keep using subtraction. Okay, but I think adding here is actually the right answer. Yeah, but it's also not the right answer because it's wildly unstable and it totally freaks out. So what's the issue? The leg relative velocity is pointing that way. Whoops. It's pointing that way. Which applies as a friction in the opposite direction. Yeah, okay. So it's the relative velocity that is wrong. This is incorrect. But it's definitely not right. It's definitely not right. I mean, okay, I think probably the real technical issue is that the ground velocity is not the ground velocity from the prior frame. It's the ground velocity from the current frame. And you know what? That's actually what it is. That's actually it. It is that ground velocity is the wrong calculation. Ground velocity should be calculated as not this at all. It's not this at all. Update comfort distance dot ground velocity. Oh, body ground velocity. Body ground velocity. Okay. So I think what I'm really doing is I'm saying the ground velocity should be where this point moved to between frames. And then I call that the actual ground velocity. And I compare that against how I moved. So I have this ground local position. I have the last local position. And I think what I probably mean to calculate is actually calculate it up here at this moment and say ground last local position, update target. I try to snap my leg to where I was standing on the ground before. Stay relative to the ground, to the current ground. So I think what I'm doing is I'm saying the ground velocity should be you know what? Let's say the ground velocity is where I want it to be. Let's say ground velocity is Ground last local position. I didn't even set this value. This is a mess. Basically, I want to calculate the ground velocity as not being ground cast, hey, tell me the velocity at this point. I want it to actually be the change in position. Not like the highest level theoretical where this could be in the future, or like where this will be in an infinitesimally small step in the future. I need where it actually ended up. So if grounded last tick, I set my target global position to be the old ground position, or I mean where I think it should be now. Or actually, not even where I think it should be, where it should be right now, with some delta. So possibly what I can say is, yeah, I kind of want to do like a last local position minus local position instead of ground velocity entirely. So somewhere I have to calculate ground velocity. And it's going to be around here, where if I'm doing something with this. So this is in the step, this is before IK happens. So this is before this extra correction that I do up here, which I just used bought at ground velocity. Yeah, so it's really just that I need to calculate ground velocity precisely. But it's going to be relative to these. So it needs to be, yeah, I'm just going to take this out. It just is not that. If I was grounded last tick, I mean, maybe what I do is I just write it here. So this would be ground local position is going to be this value. Flip that. So I have this. If I was grounded on the last tick, I can now calculate a ground velocity at this point. Ground velocity should be the difference between, I guess actually, yeah, it's going to be the difference between where it is now minus where it was, which would be ground point. So it would be I need the current transform. So this should be I'm duplicating a lot of code right now, but I just need this to work. Okay, it doesn't want to give me physics server for some reason. Body direct state. I'll just do this. I just want it like this. Actually, I'm not taking the affine inverse. I'm taking this multiplied by that ground local position minus where it was before, and this becomes ground velocity. Because grounded last tick, or at least this one up here, requires ground to happen now, but this does not necessarily mean that we had it last tick. So all right, I think I want two different things. Velocity of the ground at the contact point, and then computed real velocity from tick to tick. So basically I want to say if we're grounded now, and then if grounded last tick, I can do this, and then if grounded last tick, otherwise we use the current one. This will be ground last velocity. So it'll be really accurate at this point, and this one's just kind of accurate because I didn't have ground the last tick. So this is ground last velocity, and then I need to bring that line back. This is crawler leg. Check that. Okay, I will. Or was it? It was below transform. Right there. Is that the actual indentation that I had? Yeah. Okay. So if we were grounded last tick, use the best value. If we were not, use the second best value. So now, it's really crazy. Is it because I'm still doing... This is correct. So I'm just confused then, because this should have... Alright, let's see what this is. What is this? Why is it making that sound? There's no way a bird has evolved to actually make that noise. That just doesn't sound like a bird. Also, I'm assuming it's been fed a lot by what it's doing here, which is sad. I don't want it. It's just crazy. Bird thinks it's a CIA drone. This is such a weird looking bird. It's all white. It has a very small... It just has like a single black feather as a dot on its chest, and then it has this. Like, it has like war paint over its eyes. Wait, this one's like the same thing. It's got that. Okay. Thank you. I appreciate that one. That was a good video. That is just such a strange... Why? That bird doesn't make any sense. That bird doesn't make any sense. Alright, so ground velocity should have been calculated correctly, but I'm suspicious. So if we're ground elastic, then I take this global position. It's... Oh. Oh. Do I have cached velocity yet? That's not what I was looking for. Cached. Or cached step. No, that happens in updates. Dang. Okay. What does that thing eat? It's just snow all around. That looked like... I'm gonna make a total guess. Is that... This should be bugs, right? Yeah. It digs in the ground for bugs. That's gotta be what that means. A curved, sharp beak. Short as well. That's probably the one thing that makes sense on the bird, that it eats bugs. Okay, so I need, honestly, let me just say re-update, cache step, equal state step. I'm going to do that up there instead of in the update function. I think that had a new line previously. Cache step added there, removed there. Yep. Okay. So now I have the cached step for everything, which means anywhere that I'm just using state for state step, I can probably take it off. Okay, yeah, I'm gonna say that. Update target delta. All right. This might not be a good refactor, but I'm going to do it anyway. And then now this is unused, so I get rid of it. Update target no longer uses that. And then this is using this, so I would just do cached step. And now it is not using state instead of update. I think it would make sense that because of the way the updates run and they shouldn't be modifying state, they should just cache everything in pre-update. That's exactly how it should work. So there's pre-update, check early step, which doesn't do anything. And then there's that. This is all a bunch of state step. So anywhere I see state step, I'm going to replace it with update step transform and update comfort distance. I think maybe I just use cached step. So I can pull a parameter out. Update comfort distance is just very simple as well. Working on the API for my game? Yes, I am. But this is untangling stuff. Alright, the fewer parameters I have to keep in my mind all the time, the better. The more I can just say, alright, anytime I see cache step, that's the step for the whole tick. It's better than saying, what is state, what is step, whose state, my state? Right? I have to remember to pass it to functions, like, nah. Okay. Where was I at? Right, so I needed that so that inside of update grounded, I wouldn't have to pass a new parameter to calculate this velocity. Yep. And that's that. Too many arguments. Of course. Because it doesn't need it anymore. It only needs it once. Alright, so it still does rotate the wrong way. How? I'm gonna fix that eventually. That flashing Y every time I drag one of these, because this thing is dumb and does dumb things. Alright. Okay. So my only assumption there is that I'm still calculating it wrong. It's still incorrect. So I'm calculating the global position there. I'm transforming the local position from this. Ground last velocity should basically just match leg velocity is what should be happening. Ground last velocity 70735. These are completely different values. These are so different, it's ridiculous. They're not even close. These are so different, it's not even close. That's nuts. Go back to this camera. You know, let me just see what. Yeah, what did you think? What think it was? 02, 01, 02, 03. These are just so dramatically different. It's insane. Whoa. This is the first frame. I'm gonna skip through all the legs. What's happening right now? Weird. It was like doing like several ticks without even a single frame going by. Okay. Alright, so this leg is moving. The first leg has some good spin right now. Let me actually... Yeah, I want to look at that leg, because I think that leg should... It might actually start trying to take a step right now. Okay, so I don't know, because it's... 0... Well, I guess I'll look at the first one to see. Yeah, these are so different. I don't understand. Because this should be the same location that the target is going to. And it should be, it's like matching, it should be matching perfectly. Like, it's such a small angle change on everything, and it has 10 tries going 1 degree every time. It can line up to that point exactly. So, is the target last global position wrong? Is it a case where it's kind of being counted as an extra step when it's not? Because the idea is that at this moment, that target global position is just teleporting to the same point on the ground, which means its change in position should be identical to the ground's change in position. That's how this works. So I take that local position from last frame, I transform it by its active transform, so I get the new position, and then I subtract the old position. It might just be, it might also be a case where the way that I'm modifying it here is wrong. Like maybe I should do this. I mean, basically all this is doing is saying, this is where I was before, I want to stay here on the next frame. This is where I am now, this is where I want to stay on the next frame. So then I do end up making it there. I do stay in that position. I don't know, maybe I should try to do it like this. Maybe it should be up here where I say the ground. Oh, no, it is wrong because I'm reading it not from the right position. I'm not reading from the right location. I'm supposed to be reading from where I actually was the last tick, which is the ground last local position. So am I looking for... There's something going on with how these should be multiplied together. Okay, so basically ground local position. This is also just wrong. This should be the target node. So what I'm actually going to say is instead of there, calculating that there, I'm going to calculate it in here. So I'm going to say oh, please. Okay. I know what the problem is. I'm technically reading a different... I'll be exact. The center of the purple sphere is where I'm reading the ground change in position. This is where I'm reading where I actually want to be. So I'm saying, here's my leg velocity from the center of this green circle to there, and then I'm reading my ground velocity as being like the edge of this green circle to the center of the purple one. So those are obviously different velocities. Because we're rotating. So I guess the idea there is that the ground velocity should read lower than the leg velocity. Is that right? Smaller absolute values. 229, 2... Yeah, exactly that. So the ground last velocity is reading as a lower absolute value than this one. Okay, but I know that's what the issue is. I know that that's the issue. So I need to compute ground last velocity as this one's, I think, yeah, the ground local position I think is still, oh no, it's actually not right. Ground local position is going to be this value. our ground last local position is going to be, it should be this value. Though I guess it's also not being updated in this case. If not is stepping, we return here. Otherwise, we calculate it at the bottom. Okay, so I'm going to say this is still fine, though. Maybe what I should do is I should do instead of doing this here, I should probably save it here, where every frame that I'm grounded, I remember where I am relative to that ground position. So right after update target, do I turn on grounded here? Technically I don't, but I also don't even use it until there. So I guess it's fine to just calculate it. Which this should just turn it off before we return. Yeah, is stepping is turned off right before we return. So that's good. Okay, this is a good simplification. Because that code did kind of suck. Stay relative to the current ground when not stepping. So this is the ground last local position. But before I set that, I do have... I just need to have the ground velocity before... I'll leave ground velocity calculated here, even though I don't think I'm going to use it there. I'm going to pull this out of here, because I only have to calculate it down here. No, I think I should calculate it here. So this is going to be where the ground is now versus where it was. But I don't know where it was yet because I don't have the now. Yeah, so I actually can't calculate it here. I need to know where it is now before I do. Basically right here before I do this. So this means ground last tick means that I definitely had this value from before. So what I'm going to do is I say this is where I am now and this is where I was before. So if I have this this, so I save it first. So now I have where I am now, which is current local ground. I mean, I think I can technically calculate this as a vector and then transform it again, but I also don't really want to do that. Well, I just have a last local position. I don't know where that was. I have the last local position, but I don't have the last transform. Right? That's the problem. I don't have the previous transform. Which is what I would need. I would need to know the previous transform before I change it. So if grounded last tick, could I just set last local position as that value? Yeah, because this is where I'm always updating it. So I could save last local position as being the old transform by this to get the global. Okay. This is horrible. Ground at last. Okay, let me just... I'm just gonna do it. There's no issue with making more variables. In fact, I'm going to drop position entirely. Now that I have a local and a global. Otherwise, it's going to be confusing which one I'm talking about. I have to look in the middle instead of like at the end, which would be preferred. Okay. So up here, the ground last global needs to be that old transform. This is before I've even moved. Oh, okay. I do have the target last global position, so I have it here. Target last global position. Yeah, I have it here. No, that's not right. It should be... Wait, is that right? That is right. Kind of let's take ground last global. I think that is correct. It is the target last global position. And I'm checking to see where that moved. Yeah, I'm going to put a note here. Note. That's where the target node ended. That's where the target bone ended. That's where the target bone was after IK physics. So I say this is definitely where I was standing on the ground before, is the target last global position. So I don't even need that, because this is not updated until up here. Okay. So I can drop this, but I'm going to take this comment and move it up. I need that comment now. So That's leg velocity, where I am versus where I was. And where I was is going to be where I was versus where the ground is now. Quit confusing me with weird stuff. Okay, if I was grounded on the last tick, I'm grounded now. I'm not stepping. Oh, do I need to track that? Well, it's more like apply ground forces is turned off when I'm stepping, right? Is grounded and we're not stepping. Yeah, okay. So I don't care about anything here, I think. Wasn't it? No, it's up here that I'm doing this. So if apply ground forces, I calculate ground last velocity should be taking ground. I think it's taking last local, right? Oh, no, it should be where it is now versus where it was. So where it was is actually target last global position. Right. Also, I'm not using this until down here anyway, so this can just come back down here. I didn't need to keep track of it like that. This is doing some weird double reference thing where it can't compile itself because it's failed to compile itself from a different file. Okay. So the velocity is where I was on the ground. And that's set. I know that for a fact, and that's where I said the ground was last tick. Compared to basically the position that it should be at now, which is ground last local, which hopefully is just kind of repeated in here, right? Yeah. Hold ground, state transform, there. It's perfect. Nothing is moving. The circles are rotating, which means the whole thing is rotating. All right. I've done it. Though it seems like I have to keep doing this. This is probably the third or fourth time that I've done this to make it work. But now, it's gotta be the last time, right? It's gotta be the last time. Push. It is a little bit struggle here because I think it's just things are... I think it isn't able to like stop itself from rotating. Whoa, okay, it's trying to crawl on me. Don't do that. It does have a bit of a weird thing where it seems to like walk onto and off of something. But honestly, I think it's probably just more like in terms of like friction being weird still. But the legs should just be correct now. The legs are just saying like, yeah, this is where I am, this is where I was. Alright, I broke him. No. Oh. No. Okay. Oh. Wow. Okay. It actually got back up. Alright, what do you think about walking right now? How do you feel about walking? Not so bad. Yeah, it's got some weird bouncing happening. I think what I really need to say is that when any of these legs are outside of the comfort zone, it needs to apply that as like some friction force, right? It needs to say, I guess just more like the direction, right? Back towards the center of its comfort area should be like probably a friction vector, and it applies based on how far away it is. And yeah, this is just a problem with my friction calculations right now. It really struggles with like specifically the negative Z or just the Z axis in general. It just can't handle it. Can you go up? Can you go up now? Or can you still currently go up? If I try to make you go up. Can you do it? Please do it, because this one's really hard to do. I'm gonna ignore that. But yeah, pretty much it can do it. It can still do it. Alright, walk over this way. You're falling? That's fine. It's probably fine. It's probably still just friction being weird. Definitely is, because when it stops, I was even seeing this on flat ground too. But now I think I'm just going to really ignore it because this is just... It's not able to apply friction to like stop itself from falling. It should be having like pretty much perfect anti-gravity. But it just can't like fully stop itself and it's just going to fall. Okay. But I think it's pretty good. Yeah, it does have this weird walking thing where it kind of wants to walk into the thing that's pulling it. Which I think could just be solved with comfort zones. It wouldn't do this with the... I mean, a better like central body trying to stay still and not like let itself be dragged around. Okay. How do we feel about walking up a wall, an incline, just like a plain incline? He's out of here. Nope, go away. Okay. It probably can't do it right now. Also, this is on the z-axis, which it just struggles with. I have some issue somewhere where like the x-axis is just particularly, or the z-axis is particularly difficult to work with. Wow, it just hates doing this. It super hates doing this. It refuses. Alright, we'll come back down. It can't even come down. Alright, we'll go sideways since you love to go sideways. Yeah, it's just like... Oh, is that the z-axis? No, thank you. I can't walk on that. Alright, so when it's on here, it's fine. Also, I would really like you to stabilize a little bit. That'd be great. Could you just stabilize? Let's go slow motion. Alright, so the legs are still stepping correctly, which is great to see. So should I even mess with that? I think I still need the legs to be in a more general state for this. Alright, but this is good. This was a good improvement. By improvement, I think it's actually more of a fix because it just wasn't even rotating correctly in the first place. Break things, fix them. Break things, fix them. That's all I've been doing for a while. What? Oh, this is crawler character. Where? Here. Here. There. And I need to turn all the debug off. Don't tell me I had this open. Okay. Yeah, I'm just gonna turn this off. I think you should always stay as the default false in code, and then I turn them on when I want to turn them on. It's just the problem is that there's 6 different legs, and I have to turn them on for every single leg. So it's not like I can toggle this for all legs at the same time. Maybe I should. Maybe I should copy these parameters to a debug section here so I can just turn it on for the whole crawler. That would be nice. Because then I can do that and I don't have to touch the code anymore. And then it would also override it. Alright, I'm going to do that. I'm going to throw this into a debug section and basically just copy this one for one into the crawler character. But I'll do that after I send my current changes. Also, some variables I'm probably not using, so I'm going to double check that. I think I'm not using... This is crawler leg. Not used. This one's like not really used. I think ground offset is actually saved by crawler character. Yeah. I'm gonna document that. I think it's still bad. If I want the main body to keep track of its own offset and that one to be like the deciding factor of what the offset is, I probably should just have a whole vector of offsets that the crawler character tracks. And so then they're not tracked per leg anymore. Well, they'll be tracked per leg, but the leg doesn't. Leg doesn't save it. The crawler character just has a vector of it. Okay. I have last local, last global. I don't think I'm using... Yeah, I'm not using last local or last global. Last local I'm using? Yeah, I use that one. I just renamed it. Though, should I rename it? I should check ground location as where the target bone was after IK physics. That comment doesn't make sense there. So I'm going to move it to where it does make sense, which is somewhere around here, where it's actually calculated. In fact, this very line needs that comment. Commented there. We should check ground location as where the target bone was after IK physics. Which is why... Okay. Okay, there's kind of a lot of nonsense in here. I think I might be able to just send... I can't, because that split actually contains both. Yeah, well, I messed up. Whatever. I needed it in one place, and I said, why not do it everywhere? Because I may as well. And then I have the platform, I moved those. That I don't like. All of these have picked up some stupid thing. They all picked up some stupid thing. Because I want to commit this scene change to the world. So I need to fix that. I guess it would be rotation that I type in 90 again. Does that fix that one? No, it still just makes it dumb. 18 centimeter step, which is this one. Okay, what if I leave all these with no rotation and I rotate the main thing? Which is simple, because I can just drag them out like that. Rotate this negative 90 degrees. And then put them back in. And now these should have no rotation. I guess I went the wrong way. I think that's fine. Maybe I was right the first time, actually. Okay, some of these have better values, but some of them do not. That one just makes me so upset that it stores it as this value instead of 0. Because, like, technically what this means is that this has, like, a scale applied to it. Right? That's what this means. There's some non-linear scaling. Technically. But I can't fix it. Stupid. They were all nice before, though. They were actually all nice before, and now they're not. Okay, I'm gonna go manually fix that, I guess. Because that's just super annoying. Just select that type 0. Oops. That's just silly. Okay, let's open up test scene and hit save. And see what happens. Uh-oh. Did I forget a comma somewhere? I must have deleted a comma by accident. I must be missing a comma. I see. Okay. So what the hell just happened? What do you mean parsing error? I mean, it's a missing comma. I just have to find it. There it is. Okay. 18 centimeter step 45-2. There we go. That was very difficult to find. Okay. Alright, so what I'm going to do is I'm going to take this whole thing and I'm going to move it like so. Hit save, and please don't reapply them. Awesome. It worked. And then I want to see if this one has maintained scaling. Okay, good. All right. Let me put this in a nice place, and by a nice place, it's going to go on the spinning table. Slightly elevated. Right, player should be 125 then. Just don't want to be adding in any of these like crazy values. So make it 11.5 and 4. Or 0.5, I meant. Yeah, 11.5 is supposed to be the same that this one's at. Yeah, and they both, that one I'm pretty sure is aligned perfectly. Okay, good. That camera 3D has some crazy transform. Because of course it does. I'll go fix it then. Right, and then it was the camera, so I'm going to move the camera and then place it back, just to make sure it's not. It's going to save correctly. Okay, good. Elevator 2. That's fine. I know that 0.05 is not a good value. Oh wait, apparently 0.05 is a good value. Okay, so I guess I'll go fix those then. I mean, if they just had not their insane string to number, number to string converting library, which is like 1,000 lines long, and in basically just magic, this wouldn't be happening. I would not have to deal with these stupid things. So I moved the elevator and the slider, or slider 2. So then to be sure, I'm going to set this to like that, and then elevator 2. Because the thing is, it can read in that perfect value and then write out the perfect value. It's because one time it becomes non-perfect in the editor, and then it saves this non-perfect value, and now it's stuck on that value. Even though it could, in theory, perfectly represent it. Okay, and it's just broken it again. Alright, whatever. And that's a different value as well now. I don't think it used to be that. I think it used to be a higher error than that. Whatever. Oh, and apparently that one can represent 22.2 and 12.9 and 10.9 perfectly. Somehow. Even though those are obviously not perfectly representable and forget it. Just forget it. Delete that node. Alright. Right. So now caches delta times in removes need for passing state or deltas to several functions. I'm going to say, yeah, precisely calculate from position changes in target ground positions instead of from internal velocity values. Instead of from physics body state. And then top. Also update test world Elevated platform with platform with elevator. Added platform elevator. And then this will be what room do I have here? Not enough. Crawler Lake now caches delta times and pre-update moves need for... This is way over now. Whoops. And apart from the test world, precisely calculate this. Precisely calculate ground velocity from position changes in target ground position instead of from physics body state, making like friction correct. Okay, and I'm good with that. All right. Now I think I'm ready to do this. Okay. Change step behavior to be an internal state. I can unexpectedly move from the ground. So I guess the idea is that the legs are... I think it needs to devise a set of rules for the legs. The legs want to stay comfortable. The legs want to stay on the ground. I think those are the two... Yeah, those are the two goals of the legs, right? An individual leg. Also, there's like a thing with like complex systems and individuality where the best solution is for things to behave selfishly. So, if a leg is uncomfortable, well, I mean, mostly selfishly, it's, you know, the body is ultimately in control, and I model that by saying a leg should not take a step if it would negatively impact some other leg. Okay. So I'm write this here. Goals of a leg. Individual goals. One. I think the biggest one is probably stay comfortable and stay on the ground. Those are the two things it wants to do. It values being comfortable more than being on the ground. I think that might be an important thing to note. It should probably value, I mean, I think of it like a value function. At what point is it so uncomfortable that it would rather be comfortable than being on the ground? You know. I think it's it. Actually, I think it's it. If it is not comfortable, it will come off the ground to be on the ground in a comfortable place. So what should it do? I guess one. Okay. Algorithm, I don't know. Algorithm. If the leg is not comfortable. It might even be a thing where there's some kind of switch where it says, all right, I'm not comfortable and my legs are telling me that I can't move. I give up. I'm gonna not be on the ground but be comfortable, which would be like a leg lift, right? So this is where that leg lift comes in, I think. Do I have this? Well, this is part of the my real to-dos, which is actually just this list, but I think I restructured it. This. So I'm gonna solve this right now, actually. I think I can solve that now. If the leg is not comfortable... Okay, let me say this. If the leg is comfortable... If the leg is comfortable and grounded, stay on the ground. And then that one's done. Otherwise, I think one, if we are not grounded, seek comfortable position, hovering, seek comfortable lifted position. If we're not grounded, kind of all bets are off. Just move the leg to where it would become to its comfortable area and just stay hovering there. There may also be a thing where if it's in a setting that there's like holes in the ground, this is probably a case where I have a future possibility of, yeah, I'm even gonna mention it here. Future goal, increase comfort region until ground is found. And I think this is the case where it would just use like a cylinder cast instead of a sphere cast. No, cylinder cast doesn't work. I definitely have to have the sphere cast. So I don't know. There's kind of like an issue here where what it would need to do is locate good ground that has a good vector. But if there's like sharp corners, that sphere is going to keep hitting that corner over and over, and it's going to say, oh, this is not a good corner until the sphere... I would have to increase the size of the sphere until that vector aligns, but then it's still like right on the very edge. I don't want that. So I think what I would do is I would have... I guess I could probably just run like a ring. That might be fine. Yeah, I'm not gonna increase comfort region and ray shape casting until suitable ground is found. Yeah, that's a future goal there. If not grounded, seek a comfortable lifted position. Otherwise, I am grounded. Currently grounded. I think the question here is I need to ask all neighbors Kojima made an AI short film. It's Jover. What is it about? And is that real? Because sometimes you just like to come in here and make something up. So. Ask all neighbors. I guess it's more like ask all neighbor, not really for permission to take a step, but for permission to, what's like a, I feel like there should be a word for this, like leave the ground. I'm just gonna write leave the ground. What does this mean? I mean, I guess that's it, right? If all neighbors are okay, let me say, yeah, this is more like, okay, so this is more like taking, like, what does taking a step mean? Taking a step means I found ground, I want to move the ground. Okay, so let me see this. Let me say this. If we're not grounded, seek, seek comfortable grounded position. If no grounded position, no ground available, increase comfort region and do ray shape casting. That. If we're not grounded, we seek a comfortable grounded position. If no ground available, seek a comfortable lifted position. Otherwise, we are on the ground. We're not comfortable. We are on the ground. Ask all neighbors for permission to leave ground. So I don't really care about being, I don't really care about having a place to walk to. Or maybe I do. Maybe I would say if I'm on the ground, ask all neighbors for permission to leave the ground. If all neighbors are okay. Let me think about this. It's more like I don't want to pick up the leg early if I don't have a suitable target ground position to move to. I think it would rather prefer to stay on the ground. Yeah, let me say this. If currently grounded, and suitable ground is available, ask all neighbors for permission to leave the ground. Jeez. If all neighbors are okay, I'll say take a step. If all neighbors are okay, take a step. And then Rada video AI. Do I even want to open this? Ad. I like that the ads are just not there. That's cool. I mean, nobody cares about that. I don't know. That's weird. That's just weird. Apparently, it seems like someone high up really liked his game. Even though probably no one else did or cares. Players of that game probably don't care about Prada. People who care about Prada don't care about the game. That's probably just what the mistake is there. There's just a bad mix. Those two things are just completely unrelated and just probably made everyone unhappy. If all neighbors are okay, seek new ground position, take a step. So neighbors are not okay. So there's something that needs to happen when the neighbor is not okay. What's Prada anyway? It's clothing. It's like, it's probably more than clothing, but I think generally you can think of it like Supreme. The Supreme brand. No, it makes sense. Why? I don't know about it. Yeah, it's the type of thing that you only care about because you're in like an echo chamber and you have a ton of money and you think clothing should cost more than someone's like yearly income. I need socks that cost as much as a computer. When I could probably get a bundle of socks that the price is like an average of 50 cents per pair or something. And they're probably better. I think it's the really great thing about clothing is there are cheap clothes that are just, I think, provably better than very expensive clothing. The shirt I'm wearing right now, I bought like a 2 bundle pack, which had like, it might be like 4 of the black shirts and then 1 gray shirt for a job. And these are just the best shirts I've ever had. They're like, I don't even know what material it is. It's not cloth. They're very breathable. I've had them for probably 2 or 3 years now, and I have not noticed any degradation anywhere. Not a single seam has broken. Not one. I got them at Walmart. Or probably Target, actually. Yeah, it was Target. I just walked into Target. I was like, I just need some black shirts that are like gonna be good. If they get wet, the water evaporates really quickly out of them. It's just perfect. It's like great clothing. And I'm sure the average cost was probably like $1 or $2 per shirt. Okay, currently ground is suitable ground is available. Ask all neighbors for permission to leave the ground. If all neighbors are okay, seek new ground position. Yeah, here's... I feel like I kind of want to step out. Let me do this. Otherwise... tap these out. Otherwise-o. If we are not grounded, seek comfortable ground position, take a step, seek comfortable lifted position. This isn't really a force lift, but I'll call it like a temporary lift. If not grounded, this if currently grounded. I need to say like I need to say like terminate or something, so I know that we're done on this in this case. And I'm gonna do like that's weird. This is so weird. Stop behaving this way. Why is it like this? This is so strange. Well, as we are currently grounded, I'll say this. Otherwise, if suitable ground is available, ask all neighbors for permission to leave the ground. If all neighbors are okay, seek new ground position, take a step, terminate. So we're done. I don't know. How do I... terminate there. I don't know how to organize this. There's just like too much indentation happening, and it's bothering me. And then I guess I have an otherwise here. If suitable, I mean, it's more like if suitable ground is available. Oh, what just happened? I hit like shift delete or something. Ask all neighbors for permission to leave the ground. If all neighbors are okay, seek new ground position, take a step. Terminate. And then here's the otherwise. If no suitable ground is available. So basically this means I don't have a future step target. To do, I don't know yet. Ask all neighbors for permission to leave the ground. If all neighbors are okay, seek new ground position, take a step. So I have suitable ground. My neighbors don't want me to take a step. So I think this means when does it decide to say it may just be the case that I'm just not comfortable, right? It's not really whether or not I have suitable ground or not. It's more like I'm on the ground right now. I'm not comfortable. If I'm not grounded, I don't care. I'll just float, right? Until I get ground. If no ground is available, yeah. If suitable ground is available, I'm basically just thinking that the logic may just need to be the same in a way, where maybe I have a timer or I have some distance that I'm allowed to be outside of my zone. There's also the case of maybe I have a high relative contact velocity. If my relative contact velocity exceeds some value, like maybe it's half, that could be the drag case, right? If my relative contact velocity exceeds half of the body's current speed, then I know that I'm applying a lot of friction and I'm dragging the whole body, so I'm just going to say, all right, I give up. I'm just going to lift. I don't care anymore. Maybe not even that. Maybe it's more like a timer. If I'm exceeding it, I start a counter, and when I reach half a second of dragging, then I force myself to lift. Also, at the same time, there's the other question of like what is the answer that I would have for other neighbors asking me. I think in this case, I would say this is probably the case where it's like really selfish. If a neighbor asks me if it wants to step, depending on which type of neighbor it is, I just say no if I'm uncomfortable. If I am grounded, if I'm not grounded, I say, I don't care, go ahead, do whatever. Or maybe it's more like if I'm seeking some ground. If I am in like a temporary lift, I say, I don't care, do whatever. If I am not in a temporary lift and I'm traveling to some ground position, I say, no if you're adjacent to me, and if you're across, which means you're allowed to take a step with me, I'll say, yes, but only if I've like recently left the ground. I'll say, yeah, sure, whatever. If it's too long, then I'll say, no, because I'm about to land on the ground and I don't want you to start taking a step right now, that kind of thing. Though that doesn't really make it. What does that mean? I guess the other question is, in that case, it would be, I'm checking my. Oh no. I think it's more just like the relation. So whenever a neighbor asks me, I just check my relationship to it. And I say, if you are across from me, you can step with me if I've recently left the ground. Otherwise, you cannot. And if you are adjacent to me, I say you cannot lift if I am actively seeking ground. Or if I'm uncomfortable, you can't. Like, wait for me, right? That kind of thing. I think that's like the simplest way to do it. All right. I might even have some kind of mapping where every leg can cache like early on. Or I have like a whole list of indices where the leg looks up its index, it's like its chunk, and then it looks up the other leg's index to see if that leg is currently marked as an adjacent or a cross. That could be easy. Okay. Neighbors are not okay. Yeah, I think I flip it around. No suitable ground. If leg is comfortable and grounded. Stay on ground, terminate. If we are not currently grounded, this is sort of like a early break. So otherwise, we are grounded, but we're not comfortable. Ask all neighbors for permission to leave the ground. If all neighbors are okay, seek a suitable ground position, take a step, and then terminate if that happens. All neighbors are okay. No suitable ground. Yeah, I think this is sort of the fallback here. I'm gonna say some neighbors are in disagreement or no suitable ground. Actually, I'm gonna say this. Seek suitable ground position, take a step. Otherwise, I'm gonna change this to be like a future. Expand search for suitable ground. So we're gonna take a step. Yeah, I'll do this. It does break it though, so I guess I do that. Target lifted position. say was target comfortable with this position, terminate. That's news for permission to leave the ground. So we are grounded and not comfortable. If all neighbors are okay, suitable ground available, target it. So then at this point I know some neighbors are in disagreement or no available ground. So then I think what I say here is yeah, I think the real thing is like I'll stay on the ground where I'm at until I'm tracking that I'm dragging for too long. So, and I think that timer might be like, it'll be like this. So it'll be like, it'll count up to 5, and when it is, if it's ever not dragging in between there, it probably drops it by like double the delta time. So if it drags for, I mean, 5 seconds is way too long, but that's just for an example. If it drags for 4 seconds and then is not dragging for 1 second, it'll be at 2. So instead of going from 4 to 3, it'll actually drop to 2. Or maybe it should be the other way around, where it drops at half the rate instead. I think that's better. If current, yeah, I'm gonna do this. Maybe not like ground direction. Or yeah, probably like relative ground direction, right? Exceeds is at least half the body's if current ground rail contact velocity dot the body ground direction is at least half the body's speed in is at least half of this increment a drag time value by the current delta time. And then I'm going to say otherwise decrement by half. What's this? Increment the drag value by... I actually say this by cache step. By 0.5 cache step. Do this here. Exceeds a configured value. Target a okay. If all neighbors are okay, suitable ground is available. If we are comfortable and grounded. I think it's more like whenever I set the target. Target it. I think I actually just do this here. If we are not grounded. How do I know when to reset the value? I think it's probably here. Why is that spacing different? Okay. If all neighbors are okay, reset drag time. So it's kind of like this case. I only reset it when I'm in the zone of like incrementing it. Up here, I can just leave the value whatever it is. But I guess the question is, could I guess it's possible that somehow I'm dragging and then I reset here. I need to have like something, I need to do something to drag time always, I think. I mean, maybe I do this. Maybe do like stay on ground, and then I do... not passing 0. Drag time is positive. Decrement by cache step. I'll just say this. No, I'll just do this. I won't worry about making it negative. I'll just do that. If drag item is positive, decrement by cash step. So when we're comfortable and we're on the ground, maybe I do like, maybe this would make sense. 1.5 times cash step. So you want to reset it pretty quick, or faster. So somewhere down here I need to do something with this. Maybe here is like a reset. This is more like I'm dragging and then I stop dragging and I'm suddenly comfortable. Right? This is what this case is for. Yeah, generally it should be. So I guess then the question is, should reset be happening down there? Does reset make sense down there? I guess reset doesn't make sense here unless I'm here. So maybe the reset here doesn't make sense. Because oh. I think this is the case. Yeah, let me see this. Expand search for suitable ground. There's kind of a question here about searching for suitable ground. So let me say this. It will allow me to have a 0. Awesome. Zero. Search for suitable ground. Stay on ground. If we're not grounded. Suitable ground is available. Target it. Take a step. Yeah, I'm going to say this. Target comfort. Future expand search for suitable ground. Terminate. Okay. Generally drag should be 0 here, but yeah, maybe it's like the reset here is wrong. Yeah, maybe resetting is kind of incorrect to do ever. You know, maybe I like the dots more. Instead of that. Increment. Drag down by cached step. Drag down by seats a configured value. Target comfortable lifted position. Otherwise, if drag down is positive, so there's two decrements. There's a decrement when I am comfortable and on the ground. And there's a decrement when I am not comfortable, but also not dragging. And then there's just a standard increment when I am not comfortable, grounded, and dragging. Okay, is this the whole thing? Search for suitable ground. All right, this feels right. And then I need to answer the questions of what asking for permission to see leave the ground. See next section. Neighbor query. 1. If leg is a leg is adjacent. Anti-paired. If leg is adjacent, anti-paired. I'll say this. If Actually, I think this is probably the big thing. If my target is generally to lift, actually, if they're anti-bared, if target is if targeting, I guess I'll say this. If in a temporary lift, return okay. If I'm not in a temporary lift, then I'm going to say, yeah, I think I just say, if I'm not comfortable, I return true. Dog, what you want? I literally had it earlier. All right. I am actually going to do lunch break now. So I'm going to go get food. I'll be back. And then I'll eat and continue this. Okay, I'll be back. I'm back. I have food. I'm going to eat. I'll be back. I'm back. Okay. I think I probably want to do something here. Okay, and then That makes this question a little bit easier. If in a temporary lift, I have to be very you have to be careful with this because it's possible I want to make sure that I set it up so that it's just right the first time and I don't have to come back in here and try to debug the exact reason why something is either not lifting or stepping when I don't think it should be stepping. So I think the question is pretty simple. If in a temporary lift, this is probably just, I don't know, this feels like an easy question to answer. A temporary lift happens when? A temporary lift means the leg is basically uncomfortable and has no ground. Is essentially what that means. Actually, if take a step. This might be a case where it should reset, but I don't know. It may just be the case where if we are not grounded, I think I probably reduce. Yeah, if I'm not grounded, just decrement it normally. It's positive, decremented by cache step. I'm saying decrement, but maybe that's not like an accurate word because increment and decrement are always associated with integers, which have discrete steps. But in this case, cache step is a discrete step. It's just a fractional discrete step. It's gonna be like plus 0.01 minus 0.01, always. I actually could just treat it like this, where drag time is more measured in ticks, so I don't have to deal with floating point and precision, which would be nice because 0.001 is not, probably not possible to represent precisely. I think it's called float toy. Yeah. Yeah, it's a repeating value. Oh, actually, it's not. That is a precise value. So which one of the... I feel like one of these is just not precise then. Yeah, it looks like these ones... Okay, 7 definitely... There's no way. I don't know, because at the end it does this. Which to me means it actually can be represented exactly. Okay, this one probably not. I'm looking for one where there's an obvious... It's probably this one, right? No, I don't see a repetition. This is weird. Oh, that's a repetition. Okay, but this is definitely precisely represented. Ah, whatever. I will actually increment it by... I will actually do this. Should I do cache step? I think I want to avoid any floating point stuff. But I do need to then have to handle the fractions there. If I were to multiply everything by 2, I would get a 2, 3, 1, I'll do this. Decrement by 1, decrement by 2, decrement by 3, increment by 1. If drag time exceeds what's this value? There's a... It's in input manager at the top, right here. Physics ticks per second. Yeah, it's probably physics ticks per second. Or actually I could just do... Yeah, physics ticks per second times timescale. Maybe physics ticks over timescale. No, because then this is timeless. Every tick I just increment by 1 or whatever. So I'm just doing... input manager.physics ticks, right? Which is a weird place to have it. So I might type in 1, and it would be 1 times 100. I might type in 0.1, and it'd be 0.1 times that. So it's always correct. Increment drag time by 1 if drag time exceeds x times physics ticks. Some configurable parameter. On the ground and comfortable, decrement by 3, not grounded. We're doing something here, so we'll just decrement by 2. But I have to double it. Wait, this would be 2. Yeah. So if I were to type in half a second, that would mean yeah, while it's dragging, it's going up by 2. If I type in 0.5, it would get there in 50 ticks, which is half second. No matter what time scale I'm running at, it'd be 50 ticks. Oh, that actually does matter. Does it have to be physics ticks per second? No, I don't think so, because every time I call it, I set physics ticks per second there, but I don't need to know what the scaled value is. But I guess if I'm at quarter speed, no, quarter speed would just mean, yeah, it scales correctly. So all I have to do is just check physics ticks. Decrement by 3, decrement by 2. Well, we're not grounded, but we're comfortable. Or I guess no matter what. Okay. If we're in a temporary lift, this means we basically just don't have any suitable ground. It's effectively what this means. So return nope, false. I don't know what to say here. I'll just say disagree. Okay. There we go. So whenever we are basically hovering and we don't have suitable ground, we want to tell paired legs to wait for us to have suitable ground. And then we want to tell adjacent legs. Oh, wait a second. No. I think it's the other way around. Yes, the other way around. If is paired, we're okay. If we're just sitting in the air and the other legs want to take a step, they're allowed to do that. This is because we are adjacent to something, which means we directly participate in, I think, balancing with it. Or maybe I say, if it's a paired leg and it matches our side, then we disagree. I don't want to let one of those legs leave the ground, right? Because otherwise we're going to fall. If it's an adjacent leg and, or if it's a anti-paired leg and it's on the other side, it's also probably just not fine, actually. So yeah, I'll just say, if we're in a temporary lift, disagree. We don't want to let those we don't want to let those ones lift up because we cannot consider ourselves to be a step. So at this point, we are not in a temporary lift. So I think the question is, if I am... Yeah, I think if this leg is not comfortable, it's a no. right? I also have an early step parameter, which allows a leg to lift up early. Look at exactly what the code is, because I want this code to stay the same, I think. Early step distance. This is the only place it's this is the only place it's checked. So yeah, I think it's more like this, right? If this leg is comfortable and grounded, um, attempt an early step if there's also like body has desired forward, right? Yeah, there's kind of a lot of stuff happening here. If we are grounded, if this like to remain in place before stepping again. Yeah, I guess there's like, that's the step delay, right? I don't want to take a step too fast. I guess maybe it's more like I just check. Should I check if I'm grounded? I'll write this out, and then once I'm happy with how this looks, then I will start factoring in some of these extra things that I have, which lets it really dial in. So I'm not in a temporary lift. Falling asleep while I stand. $14,400 characters. You can't see it, but it's my camera covers it. This document currently has 14,400 characters. And 2,401 words. Really close. Turtles are so dumb, why don't they evolve already to have a self-balancing wheel on their back so they never flip around? I don't know what that means. I'm literally gonna fall asleep while I'm standing. I'm just getting... just shutting down. Uh... Okay, so currently I have like two states happening right now. I've created this temporary lift state, and I've created this like targeting a ground. Right. I think the idea behind these two is that temporary lift is... I need two things. I think temporary lift will be a variable that is true when the leg is not grounded and a ground target is not available. Then targeting ground is true when a ground target is available. And a ground target is available, and it's targeting ground is true when we are, I guess there should just be specific boolean that says we are targeting the ground value, which I guess in this case would be like is stepping. Which I might just change that to be is targeting ground instead, to be a better name. I'm literally gonna fall asleep standing up. This is crazy. Okay, I'm just gonna like... Maybe I don't need to. Maybe I don't need to. Maybe I'm fine. I'm just gonna go walk around for a second. I'm not gonna sit down. I'm just gonna walk around for a second. Stay standing. Because I bet if I sit down... Psh, lights out. Okay, I'll be back. I'm back. All right. Music. Okay, we're not in a temporary lift. The other leg is asking if it can lift from the ground. If I am not on the ground, let's do this. If I'm targeting a step, okay, so if targeting target is suitable ground, so that if not is paired. So if I'm targeting suitable ground, and the other guy is not a paired leg, I don't let them step, because I'm basically lifting. I'm like, hey, I'll be done in like a second. Wait for me, right? So then otherwise, if target time is low, if time since began target is low, return okay. Otherwise, return disagree. So if I'm targeting suitable ground, the other one can start if I've recently started. So now here's the case. I am not. I'm not in a temporary lift. I'm not looking for suitable ground. The only possibility here is that I'm basically sitting on the ground and I'm kind of like doing nothing, right? I'm not actually doing, I'm not doing anything. I'm not doing a temporary lift. I'm not doing a step. I'm doing nothing. I should be grounded. So now at this point I ask, oh, this is a bit strange. So a temporary lift happens when I am not grounded and there is no suitable ground. And there's no suitable ground. So once I pass that, that means there is suitable ground. So from this point on, I'm going to say suitable ground must be available here. If I'm in a temporary lift. Okay, wait, maybe not. A temporary lift means I am not grounded and there is no suitable ground. That doesn't necessarily mean there is suitable ground. Because I could have suitable ground, I could also not be grounded. Okay. Maybe I should do... Maybe the test should be if I am not on the ground. If I'm not on the ground, there are two possibilities. Either A, I am doing a temporary lift, or B, I am targeting ground. But I think more or less I am... Let me do this. If performing a temporary lift, if... I need to know. This word like I never can figure out. If it's 2 or 1t. It's like that British English, American English variation. If targeting suitable ground. So what do I know is true at this point? Can I make any determination? I guess I can determine here. I am grounded, or performing a temporary list is not grounded and no suitable ground. So if I'm not in there, then that means one of these two must be true. So if targeting suitable ground, at this point, I know for a fact that I am grounded. I must be grounded here. So then the only question now is, am I comfortable or am I not? If I am comfortable, I probably say, yeah, it's probably just like a return if I'm comfortable or not. If I'm comfortable, I say yes. If I'm not comfortable, I say no. There's also a question here, where loops are kind of in play, or recursive something here. Basically, two legs could be paired, and they're both not comfortable. And they say, "Hey, are you fine if I lift?" This one is not comfortable, and it's a paired leg. It should say yes, right? It should actually say, "Yeah, sure, go for it," because I would like to, right? So maybe it's a question of, if it's a paired leg, I always say yes. Otherwise, I say yes if I'm comfortable and no otherwise. Okay. Does this make sense? If it's a paired leg, I am grounded. I haven't asked if I'm comfortable or not. I just say, yes, I'm grounded, you can go for it. Right, because it's like these two X counter each other, so I'm on the ground, you can take a step if you want. Ideally, this probably should allow me to cut out the early step entirely, or like the pre-update check, or not the pre-update, but the update in the middle that is just there to start a step one tick early, to get around the fact that that in the current state, it always says no if that paired leg is uncomfortable, basically. But in this case, it means yes, which feeds back to itself. So then when it asks the other leg, the other leg will say, yes, you can, as well. So then they both agree to take this step. I mean, it's not exactly that agreement. It's also that the location that I ask is here. I must be grounded and I am not comfortable. I'm going to put in parentheses. Or both. Now I'm seeing something strange. If the leg is comfortable and grounded, both could be false. Or one could be false. If I am not grounded, then I know at this point I am I must be grounded at this point. At this point I must be grounded and I am not, and I'm definitely not comfortable. Because if I was comfortable, this one would have hit, right? So this is definitely true by this point. I must be grounded and not comfortable. Which logically means I would like to take a step. But I'm going to ask and be nice. Right? So the only reason I ask neighbors is that I'm not comfortable. And I'm grounded. Those two things are true. So if it's a paired leg, I don't even have to ask, are you comfortable? I can guarantee that the other leg is grounded and not comfortable. So I say, yeah, you can take a step. Right? And also that I know that I'm grounded too. If I'm comfortable, then I say, sure, go ahead. I'm grounded. I'm comfortable. You take a step. Right? Okay. Okay, I like all this. Do I have... Okay, good. So now I want to look through here. I want to follow the full thing. So we do as we call pre-update, check early step, update, and then I get update pose. That's the order of stuff, right? So let me go through everything and see if I'm missing something, which I definitely am. All right, so the pre-update. None of this should be checking. Yeah, none of this should be checking any other leg state. So I should really not have to look at this. because it should not be asking that question. Okay, it looks good. Update step transform, update comfort distance, update shapecast. Shapecast is literally just calling that. That's all this really does. Huge debug section. I wonder if I should move these into functions. That would probably be nice to move these into functions. I don't have any changes right now. I can do a little bit of a refactor. I'm gonna put a bunch of all the debug functions down here. And debug stepcast. I don't know, something. I don't know what to call this. It should be, I'm going to start with an underscore at least. It should start with an underscore. And then I was talking about unexpected O. A lone underscore is not a valid function name. Okay. I'll call this draw stepcast. Yeah, draw stepcast is good. I'm going to go through every debug enable, target sphere. Step reset. So I guess I'll call this clear target sphere. What? Stepcast shape, stepcast vector, target sphere. I guess let's draw a step target. And I'll have like a true or false to clear it. And then otherwise it's just going to be this one. Step reason. Same thing again, I'll have like a clear. Okay. Uh, I think I kind of want to clear some of this up too. So wait, isn't... No, passing 0 means like it turns it off. Oh. I can make that actually cleaner much later. I don't think I'm going to worry about that. Okay. Oh, that's a lot. This is the ground cast. Okay. Okay. Rest area. Draw rest area. Ground normal. Draw ground normal. And this will have a clear and a not clear. That's all of them. Nice. Definitely better to do it like this, I think. So I don't have a bunch of debug stuff sitting in the middle of everything else. At least, you know, within reason. Okay. Yeah, this is a big time, or a big space saver. Alright, so the... So the pre-update does update grounded. That all looks good. Then it does update step transform, which is just... Yeah, that's good. It's just updates it. Doesn't do anything there. Update comfort distance. Very simple. And then I do update shapecast, which is also very simple. Okay. Pre-update is clear. Then it does check early step, which does some checks here. If we are not stepping, and the method call can start step may enable allow step sync. Okay, so let's check that. Can start step. Allow step sync true. Which part of this I think is that it's... Yeah, it does some... Yeah, so this is part of something I need to bring in. I think it needs to... A leg should probably try to synchronize stepping with another leg, if it's able to. Step pair window. So if I found another leg that is stepping, and it was recent, then I say, I'm going to step. But allow step sync is only true. I clear it, and then I clear it on calls, and then whenever I call this, it becomes true if I am not moving, I am not... Okay, no, this is a bit weird. So if I am grounded, and I'm not applying ground forces for whatever reason, then I stop right there and I say no. Wait for this leg to remain in place before stepping again. So will I need that? Part of that is more of the early step thing, where I may allow the leg to take a step, or definitely I need this, because when I start walking, the whole body moves forward, the target distance to where the foot would like to be standing at that moment changes by a large amount very quickly. But the leg stays grounded and stays in the comfort area because the comfort area increases. So what happens if I don't allow an early step is that the whole crawler kind of leans forward like a meter and then starts walking. And then it like falls over and it can't synchronize its legs very well. So basically what needs to happen is when the crawler starts to walk, it should use a very, I guess not really do this, but if a leg is grounded and comfortable and all of its other legs are like, go for it, you can take a step. This one should take the step if it is further than its early step distance. It should do that. And that kind of kicks it off to have the whole thing be in a nice synchronized rhythm. But then I think the other case is that depending on its motion, it could just kind of end up in a state where it's not really very synchronized. But there's a case where a leg where a leg is sitting there on the ground and it's totally fine, and another leg that it should be walking with has just started taking a step. So the question is, should this leg just say, all right, I'll step with you? Or does the early step case still handle that? I think the early step case still handles that. Where, because in this case, a lot of these checks are sort of, where do we check? Adjacent legs, so these are legs that it cannot step with, so I don't care about that. These legs that it could step with, and it's not checking that leg's comfort. It's also not checking the leg's comfort here. So I don't know. I don't know. I don't know. Alright, well I did just do like a refactor here. Yeah, I'm changing those all out for function calls and just putting the method, putting the stuff in the function. Good, okay. I mean, technically I should like run it to make sure that it's working. But as long, honestly, I think as long as there's no syntax error, it's gonna be fine. Oh man. Alright. And I also will be having a reorganization where these will change. I will rely on the crawler to decide leg pairings and keep those leg pairings up to date. So then legs can just index into their individual section, and then find the neighbor who's requesting and say, are you an adjacent, or are you paired or anti-paired, basically. Paired legs step together, anti-paired strongly should not step together. I wonder if there's like a middle ground there where a leg is not strongly anti-paired. I guess on larger bodies that can happen. You can have a non... But then it, like, when are you going to be asking the question of that leg either? I guess it's kind of like if you had, I don't know, 100 legs, and it was like a leg down here is asking a leg up here if it's paired or anti-paired. I think the result should just be no, just because of that distance. It's neither. But then that leg shouldn't even be asking that one in the first place, so it doesn't care. But that'd be the idea. But that would also be really memory inefficient. Maybe it would actually be better to check because I only really have to store information if it is a paired leg. And if it's not present, we consider it to be a non-paired leg. Or maybe I store it as an anti-paired leg, because that's the one that I think I really care about most of the time. So this is kind of like if we're not anti-paired. Sure, whatever. Otherwise, we are anti-paired. Don't do anything. If we are... Yes, same thing here. If we are anti-paired, no. If we don't have any relation, sure. If we are anti-paired, I have to be comfortable. Maybe that's a better idea. How would I structure that in code? I mean, the only way I can think of it is that it would just be stored as a list of lists, which is pretty bad. A leg would just keep track of the legs that it is anti-paired with. But then I'm back to having multiple lists instead of a single list. I just think back to that example of a particular way that particular generalization of a JSON parser implementation where you just have like a big array of like 200 elements and only 10 of them are even useful information. So you're just storing this large array. It's like you have 200 bits and you actually only needed to have like 10 bits because that's all you really cared about, right? Anything that's not in those 10 bits is like either an impossible thing or is just ignored. I would rather not store an array that is the size of my squared legs. So if I have 6 legs, I would have to store 36 elements, when really any given leg is anti-paired with 3 other legs. So it would really only need to have 3 at most. 3 times 6, so 18. So half that number. And it would scale linearly from there. So if I have 20 legs, a leg is really only anti-paired with 3 legs still. So it'd be 60 legs instead of doing like 20 times 20, which would be 400. I just don't know what that data structure is. Well, actually, if I know for a fact that a leg can only be anti-paired with up to 3 other legs, then I could store an array like that, and each leg would just have to check those 3 elements in a row. It would grab its first one and say that first element would be the index of an anti-paired leg. Second one would be an index, the third one would be an index. And if it matches any of those indexes, then it says we are anti-paired. That's it. All character cache. If is anti-paired, return disagree. Otherwise return okay. If is anti-paired, return disagree. The double negative does kind of suck here though. So I'm gonna say if is anti-paired. There we go. If it's anti-paired, if we're comfortable, return okay. All right, so now it's all just pure anti-paired. 3 bits of information per leg. Linear scaling on memory there. Should be really fast to look up because we're just checking 3 array indices. We're not scanning through a whole list. We don't have to update the list. The crawler character manages which legs are anti-paired. And I can have finer implementation there for when legs are lost. So I don't know if I have this written down anywhere. But definitely this is suitable for following a concept where these robots are hacked into. And if this was the layout, I would find it to be really easy to just update that list of destroyed legs, or update that cache following which legs are destroyed, and now the crawler missing a leg can still move. Right. Okay, good. Following down here, can start step, or check early step would call can start step. I think start step is just really simple and just like sets a boolean basically. Yeah, basically just sets booleans. Set some stuff. Is moving is actually always false right now. It's never even set. It's red, but it's never set anywhere. So if we are grounded, the question here is that I should not start walking. I should not seek to step until I have until it's been some time since I took a step. How many timers do I have? Time since last step, time since grounded. Are those the only 2 timers? Update would modify the timers. Or I think pre-update modifies the timers. Time since start step, time since last step. Time since grounded. Okay, so there's only 3 timers. Alright. So I'm just going to be aware of those. Time since last step, I think is a... This is updated. Okay, well I need to know where this is updated. I have to see it immediately. I think time since last step is zeroed on landing. On reaching the destination. Yeah. It is zeroed when we reach a step target. Is when this one is zeroed. Okay. So the concept there is, yeah, I guess the concept there is I want a leg to, after landing, stay in place for some time before it can step again. Kind of no matter what, it seems. All right. So I think that does make sense. It's like a relaxed time, I guess. I have a minimum amount of time that this leg has to stay on the ground for. Apply ground forces. I should really document this right now because I know what it is, but I keep forgetting it. True when is grounded and not stepping. Great. Which is a bit of a redundant question because I already know that is grounded is true. So the only question this is asking is if I am stepping. So if I'm actively in a step, I can't start a step. So this is actually, I think not apply ground forces is a totally redundant check here. Because you're not supposed to be able, you're not supposed to even call can start step unless is stepping is false. So not is stepping can start step. It is only called when is stepping is false, which means this check is actually totally redundant. Is grounded is true and not stepping is true. Okay. I'm going to remove that then, because I know that's redundant. Check this one on MPV, you animal. I mean, if Instagram says I can't look at it without logging in, then I can't look it up without logging in. Huh? So this guy made this? Jesus. That was like at least 2 days of work. That's at least spending 2 days doing that. Crazy. Maybe one day, if they already have like a green screen set up, and that video was like already made, which I'm assuming that's the case, no matter what. All right. That's like 10 minutes in Blender? No. No. Definitely all he did was set up a green screen and do a bunch of cropping and like tracking. That knife, all those knives were already there. That's like 2 days. That's like actually just 2 days. I would say 2 hours, but then knowing like how my estimations go and like how things happen, that's like 2 days of work. From idea to uploading was 2 days. If not, apply ground forces. Okay, so once again, this is one where it is... Yeah, again, this function is only called when not stepping is true. So all this is checking right now is if we are grounded. If we are not grounded, specifically. So if we're not grounded or we have not been grounded for very long, I feel like this one could probably drop up here and just be like, just have this check at the top, because this doesn't have any side effects until after this function is called. I did that assembly directly from FFmpeg in a single hour and posted this code bucket. Allow an early step if all legs are ready to move, and this one has enough distance to start the pair. If all legs are ready to move. So this one is further than early step distance. All of its legs are ready to move. It's pair legs. But I think I don't care about that. I think if a leg wants to move, it only has to consider, at least momentarily, that any anti-paired legs are okay with that. It should not even be looking at its paired legs. Or well, it has to ask the pair legs, because if it turns out that a pair leg is... Well, actually no, it's more like... Hang on. Do I even need to check that at all then? If we are performing a temporary lift, anti-pair does no. Yeah. If we're currently looking for suitable ground, anti-pair is no. Otherwise, if time since began... Okay, so here's a case where I say no to a leg that is not anti-pair. So I would say yes if I was recent, and I would say no otherwise. Okay. This should be covered by a step. So this covers like a synchronized step case, where if a leg would like to start, it should, if other legs are already on the ground and fine, or which would be handled here. This would just say, yeah, sure, go for it. And then in the other direction, I've started. Now this one asks me, and I say, okay, well, I'm looking for ground. You're not anti-paired. I recently started stepping, so sure, you can too. If I've been stepping for a while, then I say, no, you need to wait because This may be a case where I could simplify it, because this is the only time that I return no for a non-paired leg. Or for a paired leg. If I always return no when it is... Okay, well this is the one time that I can return yes for an anti-pair. If I am... And this is the one time that I return no for a pair. These are the only times. If I could cut one of these out, then I could simplify it to basically say, are you anti-paired? Yes or no? And then in addition to that, probably skip the entire call altogether. Like, I wouldn't have to ask a paired leg if I can step. But I think this is a case where I do want to say that, because I want to specifically disallow... I want to tell another leg no if I've been in the air for some time. I'm still targeting. I might be able to simplify it really a lot, actually. Because it might be what it really is that I just ask... I look up my anti-paired legs and I say, are you guys okay? And then that can simplify to just say, the assumption is I'm always being asked by an anti-paired leg. And the only time I should say yes is if I am grounded and I am comfortable. Otherwise, it's always no. That could be a nice optimization. That would be a very big optimization. Because that does a lot less stuff. I'm suddenly doing a lot less stuff. The neighbor query doesn't even have to be a function at that point. I'm just grabbing the legs that I'm anti-paired with and I'm checking if any of them are not grounded or not comfortable. Because they have to be grounded, they have to be comfortable to say yes. Because in other cases, if anti-paired, disagree. If anti-paired, disagree. If anti-paired, if comfortable, okay. This is the only time. I'm gonna do it. Look up anti-paired legs from crawler, character cache. For each valid leg. If it is okay, so here's the thing. It's not technically if it's doing this, it needs to be not performing a temporary lift, not targeting, and comfortable. Jeez. I'm gonna say it. The neighbor query. For each valid leg, if it is performing a temporary lift, disagree. If it is targeting suitable ground, disagree. If it is not comfortable, disagree. So this cuts out the one case where, no, this is identical for an anti-paired leg. But now this cuts out the case where it checks a paired leg to have it says it cannot step if a paired leg has been in the air for some time. This is the check that it no longer considers. And that's specifically more of a, I cannot step unless a paired leg, I cannot step if any paired leg has been in the process of taking a step for too long. Right? But that seems like a weird thing, right? I don't know how to describe this in more specific terms, but it just seems weird. I guess it's like if you're, I don't know, maybe like waiting in line or something. And no, that doesn't make sense. I need like an analogy for this. I mean, maybe there is not one. I'm sure there's one. I can't think of it. It's like I won't step if another leg is about to stop stepping. But why? Why would I say no to that? Because the question is kind of like, that question's irrelevant if any of my anti-paired legs don't want to move. So I think this more turns into the synchronization part, where I'm ready to move, but yeah, okay, maybe this is like the early step synchronization thing. I can step earlier if any of my legs have recently started to step, or the other way around. I can step early if none of my paired legs have been in a step for some time. I might be able to work this around a different way. I think this works around a different way. Ask all neighbors for permission to leave the ground. If all neighbors are okay, do that. Expand search for suitable ground. Right? So either some neighbors are in disagreement or no available ground. Okay. I will be back. I'm back. I probably should have put it on break. And also I forgot to stop the music. Alright. So now the question is, what I was getting at was, my neighbors are all fine. This. So before I reach here, or actually it's more like up here. I am grounded and I am comfortable. I can choose to take an earlier step. So maybe I do this. If suitable ground available, I need to have some kind of, yeah, I want to have a communication where how many paired legs are there? I think there's only two, right? A leg has up to 3 anti-pairs, and a leg has up to 2 pairs that it walks with. That it would like to move at the same time as. So, yeah, possibly what I do then is, let me say this. I have a neighbor query, and I have a pair query. Yeah, I think this is like lookup. This is like step synchronization where it can just be due to orientation and direction of travel changing. That a leg that is basically in its ideal position should actually take a early step if another leg has recently started, if a paired leg has recently started moving, or none of them have. Or more specifically, this is, yeah, so this is targeting a synchronization kind of thing. The leg should take a step early. Instead of doing like the opposite of this, where a leg should be denied from stepping if a paired leg has been moving for too long, I want to do this the other way around, where I'm only seeking to start an early step or synchronize with another one that has recently stepped. Okay, great. Look up paired legs from crawler character cache. Reach valid leg. If it has recently began targeting suitable ground, I don't think I need to worry about it. Yeah, I don't think I need to worry about it being raised. This is more like, well, maybe I should. If I can step early and the other leg is lifted, and then I'm going to check after this that none of the other legs are wanting to take a step, then I can choose to take that step. There's two concepts here. There's early stepping and then there's synchronization. But no matter what, I have to be early step distance. So yeah, okay. If it has recently began targeting suitable ground, return okay. If I find like that recently, if I find any of my paired legs have started to take a step recently, I'm going to take a step with them. And then yeah, I kind of want to do two things here. Pair active to false. If it is, I think if it's in the air, yeah, let me say, yeah, let me say if it is targeting if it has no target. Let me say if it has any targets. Hang on, I just realized something. Yeah, this is just like a running line, right? Okay. This is going to stop it from doing an early step if another leg is idle in the air, right? If the other leg has any targets, ground or lift, set pair active to true. If recently began targeting suitable ground, return okay. And if let me say this. Let me say initialize value pair pair inactive to true. Let me say like pair I'll just do pair inactive. There's kind of a mix here though, where let's say I have 6 legs, I have a front, the middle, left, I guess on the camera's middle right. Front left, middle right, back left. The front left is lifted. This one will not step because it says its pair is active. Or its pair is not inactive. The back leg will say, I can step because my only other paired leg that I have is inactive. So it'll try to start an early step. Then that also leads that middle leg on the next tick to actually do the same thing and say, oh, this back leg is active now. I'm going to walk with it, right? So maybe I take out this entire middle bit. You know, I think I'll just say it the other way around. If it has yeah, I think I want to flip this around. So I'm not doing this in a bit of an extra way. I'll just say I'll just write that. I think it's better. And it shows value pair inactive to true. For each valid leg, if it is targeting ground, if it is recently targeting ground. So what happens in a case where there are no paired legs? The default is to return true. Or to return okay. Okay. Yeah, that seems right. For each valid leg, if it is targeting ground, is recently targeting ground, return okay. Otherwise, set pair inactive to false. If pair inactive, return disagree. Is it the same thing here? I have the extra case where the leg has to have been on the ground for some time. What? No, allow... Wait, what? This is allow step sync. Allow step sync if I am grounded and I've been on the ground for some time. So I am grounded. So then I have the extra check that I have to be on the ground for some time. But it's also kind of the other way around. I think all I should really do is track if I have landed recently, right? Let me say if time since last step is larger than some value, if suitable ground is available and further than early step distance, ask all pairs. A pair query. Ask all neighbors. If all are okay. Target suitable ground. I may also, this actually might be a case where I want to just totally reset. But then this is happening here. So while I am in the air, the drag time is still dropping. So yeah, I don't think I have to worry about that. This is fine, right? This seems good. I guess there is a possibility that I land, ground disappears, ground comes back. And the instant that ground returns, I decide to take a step because of that. But I don't know, maybe I could make use of drag time. Drag time has to hit 0 before I'm allowed to take a step. That could be a possibility. But then it's not configurable anymore. And why would it need to be configurable? That also doesn't help with like instant stepping still. So I still want to have that actually. Because it's still possible to take that small step and then the same leg decides to take a step like instantly again instead of waiting. Yeah. Let me actually, should probably be named like last step. Okay, so kind of an issue here is that I'm tracking this grounded time and this time since last step separately. They sort of both represent the same value. It's because I'm checking them both. It's more the case that how long it likes. I mean, yeah, there's just like too many variables here, right? Too many variables. So and it also is like step delay, right? I'm comparing step delay to time since grounded. Time since last step. Self, let me count this over. Self times last step. Self grounded. Other grounded. Right? So I probably need to collapse it to a single value that starts ticking up when I've landed and resets when I'm off the ground. It clears when I leave the ground. It clears when I start to target a new position. And it starts when I've arrived at that position. And it also clears when I leave the ground. I have to be grounded and at my target to start counting. If I'm not at my target, I'm not counting it. If I'm not on the ground, I'm not counting it. If either one of those two happens, I also clear it. Well, actually, I clear it when I start a step, and I clear it when I detach from the ground. So it's a way to unify both of these. I guess you could say last. Or not like step time, but I'll call it ground time. If ground time is larger than some value, so now they're both combined. If I am not grounded, I reset ground time. I am grounded and not comfortable. I have a different place that I'm counting. I'm not count. I count drag time here, but I don't count ground time here. Also, I don't reset that here. Yeah, I only care about drag time here. So if ground time is larger than some value, so I need to have a place where I'm updating ground time. Ground time. Reset when is false. Reset when targeting new position. Take a step. Reset when targeting lift position. Yeah, just reset when targeting lift position. Temporary or forced. And then yeah, increment by 1 while grounded only after arriving at increment by 1 while grounded and no and not targeting ground. Okay. While grounded and not targeting ground. Reset when completed a step. So reset as soon as grounded becomes false. Make it 0. Jeez. When it arrives at a ground position, reset to 0. As soon as we target a lift position, reset to 0. So this means it will stay positive, but not counting. Maybe that's actually wrong. Ground time. What's the point of it? Where is it used? It is only used in the case of this. If ground time is larger than some value. I have to have been grounded for some time, specifically not targeting a step. Because there's a moment where the foot's like coming down, but it's still not at its target, but it says, oh, we have ground now. So that's what I'm trying to avoid. The step is still in progress, but I don't want to allow something else to start taking the step, even though this is technically on the ground. The point of that is there's like the extra little bit of time where that leg can start taking up some force. And then extra time after that, once it's fully seated, still taking up force before other legs lift. But then I guess I still have the thing where I want to know. Well, yeah, I guess this just becomes ground leg, right? If it is targeting ground, recently targeting ground. So yeah, I think I say, oh no. I don't want to do anything. I just had like a quick thought, like, okay, what if I did something fancy and kept the variable, but just used a negative value to represent that we have started to take a step, but that doesn't align with the variable name then. Okay, well, either way, this is supposed to combine this. Okay, that wasn't even the point of it. This was to combine time since grounded and that was actually it. Dang. Wait, so what was the point? I have a time since start step and a time since last step. Right, time since last step is supposed to be including this grounded thing. Okay, that's where the merge happens. All right, so this is merging time since grounded and time since last step. So I still need time since start of the step. Okay, there we go. Reset. Increment by 1 while grounded and no targets. Okay. So that actually handles time since last step and time since grounded. Or grounded time, or whatever. Ground time. So now I need I guess like a target time. It counts up. Yeah, probably just like a general target time, which is just incrementing while my target is moving to some location, and then resets when it's there. The one question I haven't answered is, it was like, what would the variable be for these? How do I know it's a temporary lift? How do I know that I'm targeting ground? Right? I just have a position that I'm trying to move the leg to. I guess it could be a variable that just says like target is ground, or maybe there's two separate variables. There's a I set a ground target, or I set a lift target, and it tries to move to those positions. It could be like that. I feel like it would make more sense to just have a generic target time. And then maybe I could set flags for what that target means. Because the questions are... I guess these are both targets then, right? If targeting a lift, if targeting suitable ground. This one is more specific. I want it to only be targeting ground. I don't care about the lift. So maybe that's where it's a Boolean flag that says the target is ground. We're moving to ground. Is there some other way that I could know that the target is ground, though? That's like for free, I don't need another variable for it. Alright, I think that is the difference, actually. I think the difference is I know where I want the leg to be, and I say, this is ground, and that's all I say. And then I should just have a generic target update function that just says, do we have a target? Okay, let's move to that target, right? Doing whatever it is that we do. I also just had an idea for how to actually move the targets. Because there's kind of like a 2-arm swing, right? I have code for this already to make it look nice. But if the robot was to like reduce its motor work, it still needs to know kind of like where its target is, and it needs to like intelligently calculate how to move that target position. Or like, where is it now? Where would it like to be? So I think the idea is if I'm not on, like projecting it straight down, if I'm not on that line, I start by doing a swing. Like this way, right? And then I would look at it from, I guess, assuming that I've already reached that line. So now, does the target need to go up like this? Like there's a swing in this direction, right, of the leg. So then the question is, all right, where along that do I move? Am I going up or am I going down? And then if I'm already on that line, then it's just that a straight path, I guess, at that point. So out of like 3 degrees there. The first step is to do this swing, second step is to do this swing, and then I draw a straight line. That might look really good. I'm going to write that down. And then yeah, maybe the real calculation is just I match that up, I do this swing, and then I do that. Well, I think what it is I calculate where I'm going to go on this swing, and then I save that. I save that direction. And then how do I calculate the X swing? Yeah, so compute y axis swing. Save. Yeah, save delta. Target position. This can kind of solve an issue where basically leg speed is calculated as some fraction of how long the leg has been traveling for, how far away it is from the target, and the current speed of the main body, where it has to be a little bit more like double that rate. It's probably better if I instead tune the legs as motor speeds. So doing this sort of swing allows me to tune it like that, where I have a maximum rate of rotation that each motor could apply, and I sort of generally compute that like this, where I take my target, I swing it on the Y using that speed, and then I would I guess project my current orientation as if I had completed my Y swing, so then I know, all right, once I'm at the end, what does this Z swing have to be? If Z is like the forward, what does this Z swing have to be to get like on the line? And then I would calculate, assuming I'm already on that line, do I need to go this way or that way, right? And then I think taking all those fractional pieces and then combining them together into a single new target position. Save delta target position. New position, yeah, it would just be like that step. New position would be my target's current position. I guess like rotating that vector, right? Yeah, I'm gonna... Okay, this is good. Rotate it by... It'd be more like, I think it's the min, right? It's the minimum between... the min between this angle and... Okay, it's more like... I'm just gonna write the code out. The smaller value between my swing angle and that, right? So either move by swing rate, which is some value that I set, then go like motor swing rate. I'll just call it swing rate. I won't say motor. The sine of the angle multiplied by smaller between that distance or the swing rate, right? And then I say, rotate target position. Compute. Use the axis swing angle towards target. That. Rotate new position similar to the y-axis swing, and then I would do this. Rotate target position by rotate target position by z-axis swing angle, and then this should just be a straight line at this point. Here's a good question. What if it is above? Also, rotate new position similar to the y-axis swing. So it's like I do a little bit here, and then I would well, I guess I need to know the point that I'm actually rotating it by, which is right. I would have to go in, I would have to know the bone structure. I guess I can just assume the first bone is the y-axis swing, and the last bone, there's actually like a second leaf bone, but the last bone is that z-axis swing. I think the issue there is what I really mean to do is I really mean to because the target position could be up here or something. So I think what I really mean to say is that if the target position is below this point, below it, then I rotate. If it's not, if it's above it, then I just do the straight line. I don't do the other way. Okay. And then otherwise I won't do a rotation, or maybe I just actually project it down. That's probably better if I just project it down. Whoa. And maybe it's more like it needs to be, I don't know. This might be going a little too crazy. I might have gone too far. One second. It's getting warm. I mean, this, I don't know. I think the swing is already... I might just do the swing and then just draw a straight line. That might just be what I should do. Just compute the Y swing, and then draw the straight line. Yeah, I think I just Try to keep it simple. Instead of doing that, I would. Okay, well okay. I think I still want. Here's the thing. If I want the IK, purely IK, no physics, no physical leg motors or anything like that, to work, turn on physical legs, and I pretty much see almost exactly the same thing. Then the IK needs to operate the same way that the motors will operate, where the motors have a set speed, and that speed is the same as the IK motors. So that means when I update my target, I should... I don't know, does that mean I just go to every bone, I look at the axis that it rotates on, and say, okay, let's do this, right? Is that what I do? I point that bone in the direction, say, all right, we're going to go up. We're going to swing like this. And then I look at this one and I say, all right, we're going to swing like this. Or this, it would be this one and say, it would swing down, which would be kind of crazy. I mean, I could. But I think a little bit of simplification here will actually make things probably look nicer. So let me undo to bring this back. Did I have any other? In the position of the first IK bone in the leg chain. Yeah. This line. From the position of the last in the leg chain. Right. Okay. Z-axis swing. Last like hip on the body. I guess this case would actually be the X then. Yeah, you know, let me say this, because I know which way these bones are actually set up, so I should probably just use the same terminology that these bones have, in that really Control A does that. Okay. How did that even happen? I clicked. Let's look over here. So yeah, this is the Z. So I would look at this bone and say, all right, let's swing on the Z axis, right? Swing. And by swinging the Z, I mean I would look at it from the top. And I'd have a point here and a point here. And I'd be like, all right, let's line them up, right? And then I would have the X axis right here, which I can see by looking at the Z axis. And I would say, all right, target here, we're here, swing this way. Right? So I'll call this compute Z axis swing angle from the first IK bone in the leg chain rotate it by that. Then rotate the target position all the way there. So now we pretend like we're at that location. Now what should this one be doing to get to its position? So you compute x-axis swing angle between target position and current target from the position of the last IK bone in the leg chain. Rotate new position. Similarly to the previous z-axis swing. And then rotate target position by the z-axis swing angle. Which could be extreme. So maybe I only pay attention to it as the delta thing instead. So I think this one I say rotate it similarly to new position because I know that in this case it could be very, very extreme and probably way too much. Right. So then this one will just do a general move in whatever direction. It'll just be on that line and then it'll move along that line. Then, well, maybe this is where the mid bone comes in. So I draw a line from here to here and then here to there, and I would say, all right, this is the angle you should move on this bone. But the thing is, I've accounted for this one, and then I would have to account for this one and this one. I have to account for two things, which I don't want to do. So I think it probably is better that I just, at that point, move in a straight line. But I guess I need to judge it from some... I kind of have to judge it as an angle, don't I? Because now if I purely go by IK, then it's like I'm actually computing what the IK is supposed to be at this point. I could say that I just treat it as that. I treat it that I'm far enough away from these at this point that any movement is nearly a straight line. It nearly approximates a straight line. Or maybe that's just what I do. Maybe I read from this point and I say, all right, from here, at this distance, what does a straight line look like from here? Well, this bone would kind of do very little at this point because these two work together. This one works opposite to both. And this one's mostly responsible for like pulling the leg up or pushing it down. Right? This one. I could use that. I could probably just use that one. Swing only from this angle. Maybe that works. Alright, let me try to take a screenshot here. Can I... How do I hide something? I want to hide it. I'm pressing H. That doesn't work. How do I hide something? There's got to be a button for this. Like toggle visibility. There's nothing there. Wait, what was that? Show hidden. Toggle. That's kind of crazy. Okay, I guess I'll just keep clicking until I've mostly hidden everything. I can probably turn on... I can probably turn on IK and then like pull these legs down. Turn off the deterministic. I think I have to like keep... It's just... This is just a dumb thing. Okay, because I just want to take a screenshot of this, if I can. If I can. So I can do some test. Hey, QRT42, how's it going? I am doing alright. How are you? Why does background look like that? It's crazy. Alright, so if I had... Oh, I've got an idea. I could just do this. Though I can see that I'm painting it out. Because the background is not purely black for some reason. Okay. Simply Kurt. All right. This is probably not a good color. Why did that open over there? Green. Red. More red. Alright, so say I've got my target is there and I want to be here. So the first thing I do is do the swing. I'm just going to ignore that. I'm just going to assume we're already on the plane, right? So the next thing that I would do is I would swing, whoops, from, I guess I'll just draw the line out. Swing from there to there. So the idea, can I even do this correctly? If I, how do I do this? That, okay. So the idea is I would, that just didn't work at all. Why? Good, I saw someone vibe coding a game of a 5 years devlog video. So start a new project about came from an old devlog video. Your project looks interesting. Yeah, right now I'm just working on the hardest thing that I'm gonna have to do in the game, hopefully, which is a crawler that moves with physical joints and things. I'm just trying to like visualize something before I really get into it. Is there really not a way that I could? Like, why does it? Okay. I thought that red marker counted. Around the marked corner, what it, huh? What? This, okay, yeah. Alright, who knows? Who knows how? No one's asked the question before. Apparently I just don't get it. Because apparently setting the anchor here doesn't mean anything. Do I have to, oh wait, do I have to have this? Ah. Why are we doing the whole thing? Just... transform a layer or selection. Here's my selection. Very cool, Krita. Okay. Alright. I guess I actually would like to put this there. Sure, whatever. I didn't mean to make it smaller, but that works. Okay, so I would... What would I do? Okay, my idea is I would rotate it by only the delta value, and then I would move. Is that... I could also just do this and then travel along this line. But I guess the issue is if the target would be somewhere. So like over here. Because now this has like kind of an insane rotation. Why would the target be up there? The target couldn't be up there. The target has to be like in this area, in this region, right? It could be this high up, but okay. I'm going to say that that's just not a possibility, right? So if that's the case, I just swing it by the whole thing. So now I should just have... Okay, I didn't need to do all this. I didn't have to. Alright, I didn't need it. I didn't need it anyway. But I kind of don't know what this line is. Well, I guess I rotate it and then I... Oh, right. No. So... Alright, this is an extreme position, but I'll roll with it for now. And then I need to make the whole canvas larger. Okay. What is this? Where did that come from? All right. So then I would be on this line. I would trace this path, but then I still need to keep this as sort of a rotation. So then I think the idea is... Do I run it by the second to last bone? Or I think maybe what I do is I actually trace it from this point and I determine at this distance, what is the angle that this has? What angle does this have? So I draw a line out here. And I drew it in the wrong layer. Duplicate. Hide that one. So this line would be from here. And it would go through there. So this is now my line. And I also just wonder, well, no, so I'm only using angles, and this is technically the angle that I'm using, then maybe it's fine. I can also draw it from here if I feel like this is giving too much. Yeah, I'll draw it from the second to last bone. So now this will give less distance. And then the idea would be to rotate it up to here. Right? I guess I'll do the lower angle. So it would rotate up to here. And then I would say, all right, so this is that delta. So I move it there. And then I think along this line, I probably just do it again, where I just say, from this point on, move it straight to this target using maybe just calculating from the inner bone, the very first bone at this point. I would calculate from there and say, what distance, or like what's the arc length of this distance, and then just move that distance in. And then I'd have all the pieces. Okay, that's my idea. Maybe just call this like bone axis swing angle. Oh, I know it's specifically Z. Rotate target by the full amount, and then What is the floating point thing about? What did I say? What floating point thing? Is there something here? Oh, this? I was just looking to see what if this value, what this looked like in binary. I don't know if this is right or not, but... Oh no, this is a pattern. Never mind, I see it now. It's 747A, E, 7... Wait, it's actually kind of... Wait, which one is repeating? Is it AE147, AE147? Yeah, that's the repeating pattern. Okay. I was looking to see if it was represented precisely or not. I don't think it is. Because this is a pattern and then it doesn't repeat. So. Rotate target position by that, and then I want to calculate do step. This might also be too much. Is this too much? It's good in the sense that it should allow the changes in positions to take advantage of the fact that the motors, or that there are individual leg joints. And I'm adding them all together too. That's the part of it. Every single step I'm getting more change to the position. What custom environments are you using? I am using Hyperland. Yeah. But with the parent of the last bone in the chain. And then compute a linear travel. Or I guess it would actually be, yeah, just do the steps again. Compute a linear travel. Is it possible these could be working against each other? I guess they do, right? Maybe that's the problem. Maybe I shouldn't do that. Maybe I should only do this one. Yeah, I'm gonna say I probably skip this whole middle bit and I just do a linear travel. And the linear travel will handle... How many bones are there? 1, 2. We'll handle the other 2 bones together. Yeah. Compute a linear travel. Using the arc length from the arc length from first bone in the chain to of the swing rate angle. And angle of swing rate. Apply the linear travel. Yeah, apply the linear travel to new position. Or that's the idea. Yeah, because I think if I get into it and I'm making them work against each other, then I have to go like full IK and just compute exactly what IK would do. If it were just to travel straight there, but I don't want to do that. I want to do it not like that. Yeah, because IK traveling straight there would just like follow, would turn every motor so it can just make a straight line. I think. Maybe it wouldn't. I want to make sure it follows an arc and follows the motors closely. So I think that's it for that one. Which this should be really similar to what it already does. I think I just don't have this element yet. I think I just don't have that element. Jeez. I've done so much without actually writing any code for a while. But I might be ready. No, I need pseudoprograms available. Take a step. Error query. If recently targeting ground. So I have to have a counter. I need to have this. I need to have step target time. It was in pair query. It is targeting ground if target is ground. And then I kind of just go through everything theoretically. I have to run tests on my playground scene. Yeah, I mean, this is, well, the thing is, this is already a really complicated system that's exactly what I did. I just kept writing, and then I've gotten mad at myself because I feel like I've stacked on hacks, and then I find an edge case where something is misbehaving terribly, and then I have to hack it again. So I like walked through all the code that I had, and I found several places where checks were just totally redundant, or I mean, it does work right now, but I did find some redundant checks. But this only works because I've spent so long debugging several tiny things. So it's honestly just a mess right now, and it's probably overcomplicated. I think so far this is definitely so far this is way simpler. Start as ground, and then I'll say target time is less than some value. Okay. Target time would have to be reset when two whens here. Yeah, reset when getting a new target. Or yeah. When I say reset, I think I mean to say reset. I think what I mean to say is like, what am I using it? This is a timer that specifically tracks how long I have been moving to a target. So what happens when I reach the target? I think I don't reset it to 0. I think I make it... Ground time makes sense to be 0 because if I'm not on the ground then it's 0. Target time should not be 0. It should probably be like infinity or something. But also, I'm using it as integers instead. I guess I can set it to max. I could set it to -1. Reset to -1 when reaching a target. And then that'll actually be simple too. It'll actually read out 0 on the very first frame that it starts traveling. Increment by 1 while traveling to... I mean, that one's really simple. Okay. So I only have ground time and target time. And then I would have the ground is target value, which would be updated. Target it, take a step, set. True. Same thing again. In this case. Here's the one when reaching a target. Yeah, because the question is, I don't really know when I've reached anything yet. This is like target stuff. So I'll write down here. Is it target as ground? Yeah. I'll just say reset. Since this is a number, I'll say reset to ground time. I think 0 is fine. Reset the false when reaching a target. And then, yeah, that's kind of it. Set it to false whenever I reach a target. And I only turn it on when I'm targeting ground. I guess there's a possibility that somehow I'm traveling to ground and then I no longer have suitable ground. Well, I guess that's fine, because if the ground isn't there, it will land and then not actually be landed at that point. So it'll be fine. Okay. Have I got... There's leg synchronization, which is handled. There's early step, which is handled. Those two are kind of combined. In this case, there's the early step here, and then the synchronization as well. Was there anything else that is missed? I don't care about update target. It can start step. There's a force lifting thing here. The force lift is supposed to be a debug. That might just get replaced, instead of with force lifting, it might just get replaced with like destroyed. Because I want that like to have no participation in the system. Which would change how it... Yeah, that's probably what I should do. Let me check where force lifting is. Because I think all it's used for is like a quick out when checking neighbors. Otherwise, it's just internal to not let it do anything, which it would not be getting updates anyway. Yeah, it's an early out. It's an early out. Okay. Yeah, where's the reasons? I should probably include where the reasons go. Oh, do I have? Yep. Reason. Early step. Yeah. Reason early step. Yeah, it's just early step. Target, take a step. Oh, jeez. Where are my reasons right now? I have 10. Stepping, so that's a synchronization, so that's just gonna kind of go away. Oh, maybe this is the case where I say, I think I actually take this out, don't set it there. Down here, the thing is that I would be setting reason, early step, reason, sync with air leg. Okay. So I've got those two handled. Not comfortable and wants to move. Not comfortable and then adding the keyword that I'm floating or not. Not comfortable or not comfortable, or both. If we're not grounded. Reason. Floating. It's just in the air and it's found ground, so we're gonna say floating. Grounded and not comfortable. Yeah, I've got this repeating stuff a lot. Reason. Not comfortable. Target, take a step. This is a new one. Reason. Dragging. And I guess these would also have other reasons too. So reason. Floating. I guess, right? The reasons could update in the middle. Where's my targets? Target. No target there, target here. Yeah, I mean, I guess in this case, it's actually like a reason is dragging. Immediately. And then up here, this one's only that. This one, yeah, I think I just do this. Reason floating. Okay. Do I have enough? I've spent so much time planning it, and oh, man, I can't actually do it right now. Maybe it's a good thing. Then I can review it, and then I have mistakes where I have a 2 with nothing on it. It's definitely beyond the point of having it, really. Why was it allowing that trailing space? At this point, it's beyond the size of me reading through it and be like, yeah, I can definitely say this is guaranteed to work. So I guess maybe I should just take the fact that I need to spend a day between another day before I actually get to write this and then think about it. And maybe realize some problem, look at it, and then either fix it or discover it's not a problem. I guess I should say larger than, in this case it would be x times, what do I say, it's input manager. That feels like a, oh, this is a bad place to have it. But it's the only place that I have it. Ground time is not reset in this setting. This is like purely like set target or something. It's like update target, and then I have, I don't know, update target, and I would have like update target, update position, update target position. But this is also, because I say stay on ground. I don't know, I need like some better terms for this. Okay. All right. So that's gonna be it for today. I don't know how long I spent planning that. It was definitely a long time. Well, basically since I had lunch. So, all right. Plan out new leg crawler. Target plan. Yeah. I don't know. I would like to work on it, but it's past the time. It's past my time, so I have to save it for tomorrow. Alright. Well, that's it for today. Thanks for watching. I will be back tomorrow to implement that and possibly, I don't know. I hope I get it in there, and any problem I see is just like, oh, I typoed this, or I didn't follow my plan here, and not I made a mistake and I have to like seriously debug it and figure out what the weird edge case was, and then I feel like I wasted my time. All right, I'll be back tomorrow. Goodbye.